Tell the group to start dancing.
Hey, victory dance!
I remember one time you got in trouble for it.
Okay, thank you.
Alexa, tell the group to stop dancing.
The group stopped dancing.
Can't stop, won't stop. All right, there we go. Stop, won't stop.
Okay.
Too excited.
So I've been at Seattle University for 11 years, and there have been so many changes in the College of Science and Engineering. I think the biggest change has been the fact that we have so many more students than we did 11 years ago. We've grown by over 50%. So STEM is becoming a much more popular field of study. Another big change has been the way in which we have really created an amazing culture of undergraduate research. And so many of our undergraduate students have the opportunity to stay on campus and to do research under the mentorship of a faculty member. I'm proud of the impact I've had over the last 11 years through the hiring, development, and retention of amazing faculty members who are truly dedicated to student success. Today, Seattle is home to some of the world's most valuable startups. And look at the success stories that have come out of Seattle. Microsoft, Amazon, Expedia, Zillow, Zulily, the list goes on. And Seattle has created this amazing gravitational field that's pulling in other companies. So Google is here, Apple is here, Facebook, LinkedIn, Alibaba, Tencent. Seattle is where it's at with software, and our students know that. This is why enrollments in computer science have been growing so rapidly. Seattle University is changing. The College of Science and Engineering has been the fastest growing college or school at the university for over a decade. Students are moving into the STEM fields, and the Center for Science and Innovation is a recognition that STEM is a critical part of what Seattle University is all about. We're innovating as industry innovates, and we're going to be developing new programs in data science, machine learning, artificial intelligence, so that our students will be prepared for the jobs of the future.
I'll just turn it right over to you.
Thank you. Thank you, Dr. Louis. Good afternoon, everybody. Thank you for coming to our presentation. We are Team ECE 1947, and we're here to talk about the SpotCheck project, the pattern species recognition with recognition.py. My name is Maida, Devin Dewitt, Jack Gulate, and Longfat. Our faculty advisor is Dr. Agnieszka Miguel, and our liaison is Brona Barrecha-Smith. Today's presentation will begin with our sponsor and project background, followed by the project budgets. After that, we will talk about our project results, and to make the result more visual, we will do a short live demo. After that, last but not least, we will give our recommendations to the future teams. So let's begin with our sponsor background. We have been working with Panthera organization for the last 9 months, and this is the only organization in the world that is devoted exclusively to the conservation of 40 wildcat species and their ecosystem. The mission that the organization is carrying is to ensure a future for wildcat and the vast landscape where they belong. Besides with the big mission, Panthera also have a vision of the world where wildcat can live in happy and natural and developed landscape that sustain people and biodiversity. Now let's get to know our project for this year. Panthera organization main focus on wildcat conservation, and the key step of this process is to generate accurate population estimate. To do that, biologists need to keep track of the population of endangered cats. They need to know how many of them are there in the world. So how can they do that? They set up camera traps within endangered wildcats habitats. We are working with snow leopard this year. So camera traps for snow leopards are set upon a mountain where they live. The camera trap is used to obtain quality pictures of cat. It consists of camera controlled by motion sensor. When something moving passes by, it could trigger the motion sensor and take a series of pictures. After collecting and selecting images from camera traps, Panthera biologists need to sort all of them by hand. One study can go up to 10,000 images, and it takes around 30 minutes to process each photo. So imagine biologists need to sort all of them, 10,000 images by hand. It costs a lot of time and money and effort as well. So let's put on the biologist's cat. And do you think they are the same cat or not? Make a quick guess and keep the answer in your mind. Google figure it out later on the presentation. So now Devin gonna take over.
All right, so as Maya mentioned, the cost and time that it takes to run the manual process is very large. To that end, Seattle University has been partnering with Panthera for the past 3 years, and the engineering design teams have worked on a program called HotSpotter to improve and automate this process. HotSpotter was developed by Jonathan Kroll as a graduate student at RPI, and it uses the scale invariant feature transform, or SIFT algorithm, to do the image comparison process. And SIFT is essentially an edge detector that has proven very effective when working with pattern species such as snow leopards. And when we run the algorithm, what it does is it locates key points on an image, which key point is a gradient descriptor of a small portion of that image, and it compares them across the images to find the matches. This year, though, around January, we got our Panthera's lead developer contacted us and let us know that they were no longer interested in continuing the development of HotSpotter, as he had created a lightweight image recognition program that we've taken to calling recognition.py, and we were provided with that in January of 2019. Basically, Panthera wanted to see a lightweight version of HotSpotter, and specifically they were not interested in the graphical user interface anymore, and they also wanted it to be able to run from the command line so that they could integrate it directly with their own development environment that they run. So our project has officially shifted to the development of recognition.py, and we're doing it to aid biologists in this process so that we can hopefully generate and extrapolate the population numbers for the wildcat species that we're working with. Specifically, our goals are to improve the software accuracy, ensure that the software has adequate performance, also improve and increase the software's functionality, and finally ensure that the software is manageable for future teams. With that, we're going to move on to our budget. As it's mainly a software-oriented project, we only have 2 small purchases. The first was some parallel software, which is a virtual desktop that allowed our Mac users to run Windows, as when we were working with HotSpotter, that it only ran on Windows when we were developing on it. And finally, we had some parking passes for our liaison. With that, I'm going to turn things over to Jack, who's going to talk about the work we did on the recognition script.
So the first improvement we made was the addition of the recognition class. What it does is it bundles all the information about an image into a single uniform interface. And when the script is run, the user gives the template source and the image folder source. And the original script would go straight into the image matching process. And as it needed access to each individual image or template, it would go into the computer's file system and grab them individually. Not only was this a lot slower, it also added some vulnerabilities to the program. For example, if the user accidentally added or deleted a template during runtime or moved the folder, the entire program would crash. What we did was we created this class, and the first thing our program does is it boots up, and it goes into the folder, and it pairs each image with its corresponding template, and then it also extracts the camera and station that that picture was taken at, and the date and time that image was taken at. For certain test sets, we can also implement the cat ID in there as well. And this also made it easy to add and remove functionality to our program. When we met or did our final year presentation with our liaisons, they had some final suggestions they wanted to see in the script. Because of the way we set this up, we were able to quickly implement those changes for them. The next is the addition of templates. When the original script was run, it would compare the entirety of one image to the entirety of the other. So when images with similar backgrounds were run, it would generate thousands of key point matches. And we can see an example of this here. Each line on that upper part of the image shows what it considered a key point match, and it's washing out any helpful data that we would expect to see in our output. That's where we get into the addition of the black and white templates. Each image that you have in your image source file needs its corresponding template, and this constricts the region of interest for the image matching process. These templates are generated by a MATLAB program written by a previous year's team although we use them a little bit differently than they do. They had an auto-chipping function that would take that white area and break it into 2 or 3 large rectangles and then use those for its region of interest, where we were able to take these black and white images and directly overlay them over our source image and use the actual cat's body outline as the region of interest for the image matching. This allowed us to use more obscure areas of the cat, namely like the tail, the feet, and the head, and generate more key point matches. We can see an example of this here, where we have 2 images that hold the same cat. We can see a large cluster of key point matches being made on the left flank of both cats, and it might be a little bit hard to see in the back, but there is a purple line that is connecting the feet of both leopards, which is a key point previous teams would have missed. Next is the auto-query functionality. What we define as auto-querying is taking one image and comparing it to every other image within the data set. Previous teams, when they had the auto-chipping functionality on a data set of 30 images, they could have up to 90 rectangles that would all have to be queried against each other. Not only was this slower, but the code to properly do so was very hard to read, maintain, and add functionality to. The way we use the templates, we only have 30 entities that need to be compared, so ours is quicker and it was easier to maintain and add onto. The actual process goes as such. Each image is run through the SIFT algorithm, and that extracts all the key points from that image. Then 2 key point lists are then passed through a nearest neighbor classifier, and that tells us which ones are actually matches. Then we have a third algorithm called ransack, which takes those matches and tells us which ones were actually false positives. It gets rid of those, and then the final output of this whole process is the number of the true number of key point matches between 2 images. That number is then written to a big matrix that is populated throughout the entire program runtime, and we can see an example of that here on a data set of 10 images. These values are normalized, which means all those key point matches are then scaled between 0 and 1, and that's a necessity for the input of the clustering method that Long will talk about next. We can see a perfect score of 1 that we manually add in because we expect a perfect score when we compare an image against itself. So image 3 against image 3, image 5 against image 5. And then other cells that have greener color to them indicate a higher correlation or more key point matches being made. So we can expect some correlation between images 1, 2, and 3 here, and images 6, 7, and 8. But we actually can't tell that by eye, and that's where we let the clustering algorithms do their work. They take this matrix as an input and actually spit out what it thinks are individual cats and groups the images together. So with that, I'm going to let Long talk about the clustering algorithms we tested and how they performed.
So, thank you, Jack. Before we get into any clustering results, I want to quickly go over what clustering is and how we implement it into our projects. So, clustering is a machine learning algorithm that involves grouping data into clusters. And for our project, it would take in the score matrices that Jack previously talked about, and we'll group the images that have high similarities together into unique clusters. So there are 2 clustering methods that we use for our projects which are recommended to us by the previous years, which are k-means clustering and hierarchical clustering. So what is k-means clustering? K-means clustering is an unsupervised machine learning method that aims to group data into k cluster. So k is required input into the clustering algorithm. So for our team, we have to use k-mean to detect k unique cats based on the grouping in the data sets. So we've been using a method called the elbow method that would help us determine the optimal k number. So these graphs right here are the elbow graphs, which will help us determine the k number. So these are the graphs from one data set, but from different run. So this graph shows us the elbow point is at k equals 4, whereas the other 2 show us k equals 5. So these cluster predictions from the same data set shows how the methods are inconsistent, and it also could not tell us the accurate k number when the data set has more than 5 cats. So moving on to hierarchical clustering. So hierarchical clustering has 2 types, divisive and agglomerative. So agglomerative hierarchical clustering is a method of cluster analysis that takes a bottom-up approach. So bottom-up approach means each observation starts in its own cluster, and then the algorithm will find 2 closest pair and merge them into one. And then the process keeps running until one big cluster is formed. And the results will be presented, usually presented in a dendrogram form, as you can see right here. So hierarchical clustering generated different results for a data set where cats are evenly represented and data sets where cats are underrepresented. a data set, the evenly represented data sets is where every cat has a similar number of images. So this dendrogram right here, it shows the results of hierarchical clustering on an evenly represented data sets. And on an evenly represented data sets, we usually have an 100% accuracy every time when the algorithm reaches the cutoff point. On the other hand, this right here is the dendrogram shows the results of hierarchical clustering on underrepresented data sets. In an underrepresented data sets, we know that one cat might have significantly less images than others. And when that happens, that cat would be merged incorrectly into another cluster when the algorithm reached the stopping point right here. So we have tested our methods on 30 data sets. And k-means yields a maximum accuracy at 93% and average at 64%. Hierarchical clustering yields a maximum of 100%, but yields an average of 40%. So both methods show promising results, but they do have drawbacks, which is why we documented our problems and recommendation for further developments. And up next, I'm going to pass it to Devin to talk about auto templating.
So as Jack had mentioned, we included the ability to use templates in the image recognition process. These templates are not free to create. They do require a lot of work. Currently, the way that they're generated is through a process called Robust Principal Component Analysis, or RPCA, and that process requires a series of images to actually create accurate templates, and that series of images would be something like you see on the screen here, where we have 4 images that are from the same cat. It's moving across the camera trap, and then we take that, run it through the MATLAB script, and we get semi-accurate templates that we can use. Because we won't always have access to the series of images and we don't know which cat belongs to which, currently Panthera biologists still have to manually crop every image by hand, which is a time-consuming process still. To that end, we've looked into several methods that may improve the process of creating templates, and what we found is that a specific type of convolutional neural net, specifically a mask RCNN, shows a lot of promise when it comes to creating these templates, and it may even be something we can implement in the program that would run it at the program runtime. So the image on the screen is actually from the output of our convolutional neural net that we downloaded. This is a pre-trained network, and you can see that it did find the cat. It drew a fairly accurate bounding box and then created a mask over the image that we could create a template from. The only downside, and it may be hard to see, is that the program thinks that this is a giraffe and not a snow leopard. And that is because the pre-trained network doesn't know what a snow leopard is and hasn't been trained on any snow leopard images. So that's going to be something that the future teams will have to look into. But we really think that the results here are very, very good. And then we can move on to our live demo.
So we're going to go back to those 2 original cat images that we showed. And Devin's going to show the auto cropping functionality that we have. Then the next couple images that are going to pop up on the screen are the comparisons that it's making, and then it's going to write the final picture to the output folder. And then I'm going to let Mai take over for a little bit.
So after running those 2 images on the recognition software, we achieved the result. And as you can see, there's a lot of keyboard detected on both cats, but they show no match between those 2 pictures. So the answer is no. They are totally 2 different cats. You get it all right? You know it's not, right?
So then the next functionality we want to show really quick is the auto templating. This is when the program is going into the computer system files and it's finding each image and matching it with its corresponding template. This is an example data set of 10 images, and it does take about 2 minutes to run. We're not going to go through the whole thing. We just wanted to show the functionality and all the matching process that makes. And now we're going to go into some future recommendations.
All right, so our first set of recommendations that we have is number 1 is to continue the development of that convolutional neural net that we talked about. The templating process or the manual cropping process is a pretty big bottleneck that the Panthera biologists will still have to work through, and we think this is one of the best ways to improve the entire image recognition process. On top of that, we have provided several recommendations for improving both the k-means and hierarchical clustering methods and in their detection or in their ability to detect the number of unique cats in a data set. And we also think that exploring some new methods may be beneficial as well. And then on top of that, the score matrix that Jack was talking about, currently what we fill in that matrix is just the number of key point matches between each set of images. We found that that metric does not work very well in the clustering step, and we think that research into data that will cluster more accurately and more effectively will lead to improved accuracy.
And the final recommendation we have is to integrate adaptive histogram equalization into the recognition.py script. Currently, the way SIFT works is that it uses edge detection to extract key points. So images that are taken at low light or are rather blurry, it has a really hard time extracting key points off the cat's body. We can see that in this left image where the midsection of the cat doesn't have a whole lot of key points on it. And we have determined through testing that most of the key point matches we see do come from that midsection of the cat. So this is very insufficient. When we run the same image through adaptive histogram equalization, we can see that the color enhancement and edge sharpening has taken effect, and a lot more key points are being made over the span of the leopard's body, which is exactly what we want to see. And finally, that is the end of our presentation. We would like to thank our faculty advisor, Dr. Agni Escamilla, our project liaison, Renat Baraki-Smith, the Panthera lead developer, Ross Pittman, the Panthera Corporation itself, Seattle University, and last year's ECE 18.17 for all their help. Does anyone have any questions?
Let's thank them for what we
Yes, sir.
Yes.
Couple of related. Are there any snow leopards in zoos? And if there are, what's the nearest one? Have you been there?
Yeah,
Yes.
the Seattle, is that Woodland Park?
Woodland Park.
Woodland Park, yes.
Has
Yeah.
snow leopards, and we did go in the fall.
Almost touched one. Almost touched one.
She almost touched us.
They stopped me.
Another question.
Yes, sir.
You had mentioned the algorithms running on MATLAB. What's the future implications of running it on the cloud, and have you thought about like scaling it up for multiple type of processing at the simultaneously?
So one of the original goals with the hotspotter was to start to move everything to the cloud. When we received the new script and the new scope, a lot of those goals fell away, and we were mostly trying to get the program as we had it up to where our hotspotter was working. So we haven't spent a lot of time thinking about moving it to the cloud, but we are documenting all of the program and the functions and trying to keep it as simple as possible so that when the time comes, and that is something we can work towards, that it should hopefully be a simple process.
All right, we are out of time, so let's thank them one more time.
All right, well,
And all the teams will, of course, will be available.
let's get out of here.
Good job. Good job.
Break,
Yeah.
and after all the presentations are done, so we'll get the next team up here.
Some of those products include charge controllers, inverters for off-grid and grid systems, and energy storage devices such as batteries. Some background on batteries. They're necessary in off-grid and hybrid systems. They store power from renewable energy systems like solar panels, for example, and they allow energy consumption when your panels and your generators aren't producing electricity. For example, at nighttime when you're not getting any sun, your solar panels are going to generate electricity, so that's why you got your battery there, your stored electricity for energy consumption at night, for example. So our task is to develop the battery monitor, and batteries need monitoring to maintain their lifespan in order to optimize them. Similar to a phone, it's important to know the state of charge of a battery, and that's something that battery monitors are capable of, and they also prevent overcharging and excessive discharge of the battery. And both those things are very detrimental for the battery. They will damage them, so it's important that those are prevented. And on the consumer side, they also help determine the electrical energy consumption so that the user can make adjustments if needed.
So the purpose of our project is to develop a functional battery monitoring system prototype to monitor 3 batteries and interface with other devices on the network. The project scope is to update an existing product from the ground up. Our deliverable is a printed circuit board prototype. We're going to be monitoring the voltage, current, and temperature of the battery, and then calculate the instantaneous power and daily average power consumption. Our measurement constraints are to minimize error for the calculation for the measurements and to minimize power consumption. So the project specifications are to monitor 3 isolated battery banks, collect measurements with a microcontroller. Voltage and current measurements will be taken at greater than 10 kilohertz, and since temperature doesn't change as much, we'll be sampling that at greater than 1 kilohertz. And we'll be using Outback Power's remote temperature sensor module to measure the temperature. Then we'll be communicating the data to other devices on the network through CAN bus, or controller area network, and serial RS-485. And then finally, computing and storing the daily power.
So here's an overview diagram of our system. You can see on the left side, there are the 3 batteries that our system is going to be monitoring. Each battery has a temperature and a voltage sensor. And then between each battery and its load, there is a shunt, and that shunt is going to be used for current sensing. And all the data from the sensors are going to go to the microcontroller, which is powered using battery number 1. The data then is going to be communicated using CAN bus and RS-485.
So right when we got our project, one of the very first things we did was divide it up into different subsystems, and those subsystems fall under 2 categories. We have hardware and we have software. On the hardware side, we have current, voltage, and temperature sensing, and the power supply. And on the software side of things, we have SPI, CAN bus, RS-485 communication, and the ADC, and then power calculations and storage. So for this presentation, we'll be going through each one of those subsystems and talking about.
For hardware design, we had 3 main goals in mind. First is precision is the most important part of the system. We need to accurately measure these batteries. Next, we had to think about isolation. We didn't want any high voltages or high currents going into our sensitive circuitry and destroying it. And next, we were thinking about minimizing the power consumption. There's not really a point in monitoring a battery if the act of monitoring the battery drains the battery.
Okay, so for the current sensing portion of our circuit, we're going to be taking the measurements through a shunt. And so a shunt provides an extremely low resistance path for current to travel through. And it has a known resistance, so you measure the extremely small voltage across the shunt, and with that you can calculate the current that's going to be going across it. And this is our circuit for the current sensing portion. So Reed mentioned the words isolation and precision earlier. Those are words we heard a lot over the last 9 months, reiterated many times to us. So when we were looking for chips and components for the circuit, that was the #1 things we were looking for. And so we decided on a precision operational amplifier, and it also acts as an isolation barrier, which is important because you have high currents running through that shunt. And the error that we receive on our measurements, it varies with the current. For higher currents, we're receiving a very low error, but then for the lower end, so like below like 10 amps, we're getting slightly higher errors. And also it has a very low power consumption, which is great.
So for voltage sensing, we're also using another differential operational amplifier, different from the one from current sensing though. Again, these act as isolation barriers. This one in specific is very low power and high accuracy. It has extremely low offset voltage and gain error is about 0.1%. And this is a linear response, meaning that's very easy to use in the code. So for temperature, we used a thermistor and a resistor voltage divider network. Unfortunately, resistor is non-linear, meaning we had to use a lookup table in our code. So if we have a value that falls in between two known temperatures, we have to find a way to resolve that, either rounding up or rounding down. And again, this is low power. Again, it's one of our main goals. However, if it's around negative 30 degrees Fahrenheit, the resistance starts to drop very low and we'll start drawing current, but that's very unlikely. For our power supply, we had to find a way to supply enough current for the entire system. And the biggest challenge actually was finding a power supply that would let us downstep an entire voltage range we're reading from and provide a stable voltage level for our circuit. And the chip we found also lets us enter a low power mode, meaning that when the voltage on the battery reaches a certain point, we can turn our system off and not keep draining the power. For our printed circuit board, we had a 4-layer board that is signal, power, ground, and signal. Our main design challenges in this were signal, noise, and isolation. And again, we designed this with maximizing the accuracy in mind and not really caring about form factor. And again, this is our final deliverable prototype. So more on that, you can see part of the schematic there. The isolation, we were using electrostatic discharge protection for high voltages, analog and digital ground planes, PTC fuse protection for high currents, which also is resettable, so you don't have to replace a fuse every time it's blown. Accuracy, we wanted to minimize trace distances, use signal separation, and implement as many noise reduction methods as we could.
So for the software design, we created a process. First, we'll be getting the raw binary data from measurements from the ADC via SPI communication. Then we're going to be converting the floats from the raw binary with a resolution multiplier. Then we're going to be formatting the data depending on the measurement type. As Reed mentioned earlier, the voltage and current measurements will be formatted with a linear equation, and the temperature will be needing to use a lookup table for that. Next, we'll be storing the data to a battery class object in the code, and then calculating instantaneous power. Finally, we're going to be communicating these measurements via CAN bus and serial RS-485 to other devices on the network. This diagram shows the data flow of the system. The ADC gets measurements from the current voltage and temperature sensors, and then sends it to the microcontroller over SPI. The microcontroller performs power calculations, and these are sent to storage and over the network RS-485 and CAN bus. So the embedded system that we chose for our project, we chose a 32-bit architecture because it has several advantages. It has a larger register width, more instructions per cycle, faster calculations, and it supports more peripherals. Specifically, we chose an ARM-based architecture, and ARM stands for Advanced RISC Machines, because it's open source in terms of hardware design and the development environment. It's widely available. There are many manufacturers, and it's popular, so there's many support resources. So to get the measurements from each of our sensors, we used an analog to digital converter to acquire each of the voltage samples. The analog to digital converter converts analog voltage signals into digital signals. Initially, we planned on using the microcontroller's internal ADC, but found that the resolution requirements were not sufficient. So instead, we chose to use a 12-bit, 12-channel external ADC that had an input voltage range of up to 5 volts. And we found that the resolution was great for our requirements. The ADC that we chose uses SPI communication and can read up to 9 channels for each battery. This is a connection diagram of the ADC that we used. On the left, we have the analog inputs for the battery, and on the right, we have the digital outputs that communicate to the microcontroller. For SPI communication, the microcontroller was set up as the master, and the ADC was set up as the slave. So for MOSI, master out, slave in from the microcontroller, we'll be sending an initial setup hex byte of 7600 to set up all the registers on the ADC, and then after that, we'll be sending a conversion of 80 and then incrementing that by 0.8 each time to cycle through each channel on the ADC. To get the data from the ADC to the microcontroller, which is master in, slave out, we're going to be expecting 2 bytes. It's actually 1.5 bytes because it's 12 bits of data, and that binary data represents the voltage measurement from the ADC. These diagrams show the SPI message format from the hex byte broken down into the binary. These are just to show how each of the register binary values are set up. So there's a setup byte, and then for conversion, these 4 are left depending on which channel to cycle through.
CAN bus is one of the 2 communication methods Outback asked us to implement in our system. The other communication method is RS-485, which I'm going to talk about later. When we picked our microcontroller, we made sure that it has CAN capabilities. However, most microcontrollers with CAN capabilities do not come with a built-in CAN transceiver, so we had to get one to make our CAN circuit work. We were able to come up with a final circuit for CAN bus, and we were able to send measurements and receive it in another microcontroller using CAN bus. And for message format, Outback left the design open to us, and I'm going to talk about our design for the message format in the next slides. So here's a connection diagram for our CAN circuit. In the middle, you can see the microcontroller, and then on the bottom, the 2 lines coming out of the CAN controller, the receive, RX, and to the transmit line, TX. Both lines go into the CAN transceiver, and then on the right side of the CAN transceiver, you can see the CAN high and CAN low, which connect to the CAN bus. And then for other devices to connect to the CAN bus, we're going to use an RJ45 connector. The RJ45 connector has 8 pins. We're only going to use 3 out of the 8. Pin 1 and 2 are going to be for CAN high and low, and then pin 4 is going to be for ground. So we have 4 measurements per battery, and we have 3 batteries, so we have a total of 12 measurements. However, in one CAN message, we can send up to 8 bytes, so we decided to send 1 measurement per message. And here's our message layout. First is the battery number, and then we're going to have the type of measurement. We have 4 types of measurements. Number 1 is going to be voltage, 2 is current, 3 is temperature, and 4 is instantaneous power. And then after that, there is going to be the actual value of the measurement. So Outback asked us to send all these measurements every 20 milliseconds, but since we have, since we're going to send 1 measurement per message, we're going to have to send 1 message every 1.66 milliseconds. Our secondary method of communication is RS-485. It's a serial communication standard. For consistency purposes, we're going to use the same message format as CAN bus. And for the coding portion, we are using the embed library, since it has a lot of helpful function for setting up, sending, and receiving RS-485 messages. And just like CAN, we needed to get an RS-485 interface chip to make the RS-485 communication work. And here is a connection diagram of our RS-485 interface chip. You can see we have 6 solid lines. These lines are going to connect to the microcontroller, and then the dashed lines are going to connect to an RJ45 connector, which is the same one we're using for CAN.
So we can talk about our results real fast. We were able to measure everything well within the error limits, as well as store and communicate all these measurements and power calculations. Unfortunately, the PCB is now 16 days late in manufacturing, so we haven't been able to deliver that yet. But you can see a functioning prototype out at our board if you'd like to see it for a single channel. And last, we'd like to say that this is a really great opportunity to apply what we've learned in the last 4 years, from analog circuit design, PCB layout, firmware development, design, bench power testing, serial communication, and working on soft skills as well. So really thank Outback Power for this opportunity. Are there any questions?
We do have a couple of minutes for questions.
So since you didn't have hardware to test, how did you test? So we have a breadboard prototype that we ended up testing about 4 months ago at Outback. And we are just using that right now to prove everything. And we have 2 breakout boards for our CPUs to communicate back and forth.
Since your error level was higher at low current readings, what do you attribute that error level to?
It's to do with the resolution from the current sensing.
Yeah, so the voltage differential on a shunt ends up being really low at low currents. So trying to measure the difference between like 0.001 volt to like 0.00011 is very difficult.
So your resolution for the error didn't change, it's just because you're on a smaller scale.
Yeah.
I think we have
Does Outback Power provide modules to the Kilowatt for Humanity project? Since they're out there. Oh. Cool.
Did you have any challenges working with the CAN bus?
So we used the embed library. It has a lot of very helpful functions, so it made it so much easier to work with CAN bus. We didn't have to look into very low-level details.
Yeah, I was going to say, just adding on, most of the problems that we encountered were actually with SPI communication, just all the setup hex bytes and reading all that.
Which was easier, CAN bus or RS-45?
I liked CAN bus much more than RS-45. Yeah.
So sampling frequency, like 10 kilohertz, did you guys find that being too high or too low, or any opinions about sampling frequency for like temperature?
For sampling frequency, 10 kilohertz actually seemed pretty low in terms of getting all the clock signals correctly configured for the microcontroller. But then we just figured that we could just stick in some delays and it would work itself out.
All right, let's thank
Should I get the other computer? Sorry, I'm gonna.
I don't know. It might have been Devin.
Devin?
It might have been Devin.
everybody. We are Team ECE 19.4, and today we're going to present to you our senior design project that is improving the KiloWatts for Humanity data logger. Today's presentation will include introduction, then we'll talk about our design approach for our project goals. That includes enclosure, printed circuit board, and the software. Then we'll talk about budget and the results, and finally a demo at the end. Our team, ECE 19.4, includes me, Chao Hun,
myself, Dominic Berge.
I'm Josh O'Hara.
and our faculty advisor is Dr. Shani Abraham. Our liaison engineers are Dave Goldsmith, Alex Van Bolden, and Carrie Smith. All three of them are a part of the data acquisition team of KiloWatts for Humanity.
Our sponsor is KiloWatts for Humanity. They're a Seattle-based nonprofit that focuses in rural electrification in countries, less economically developed countries. A lot of their projects are off-grid photovoltaic kiosks, and their main mission is to develop sustainable projects to improve people's lives. Here are a few images of kiosks that KWH has implemented in Zambia. All of these communities are remote rural villages that are not currently connected to the grid and may not be for many years.
I'll give a little background on our project. The data logger's main functionality is to collect, package, temporarily store, and then transmit data collected on the microgrid systems it's paired with. KWH personnel can use that data back in the United States to better maintain their kiosk systems, to further their research in alleviating energy poverty, and to develop future designs that are more efficient or better well-rounded. This is what the data looks like when it comes into the server. The top graph shows energy generation. You can see how it spikes in the morning when the sun comes up. Energy consumption is on the bottom. Those little ripples over the top of the graph, that's a freezer kicking on and off to maintain temperature.
The KWH data logger has been an ongoing collaborative project between Seattle University senior design teams and KiloWatts for Humanity. Last year's senior design team, ECE 18.5, designed and constructed the unit shown on the right. KWH has identified a few shortcomings with this device and tasked us with improving upon them. Those shortcomings include unsecure internal components, including the Pi and PCB. There is no external port access to interface with the device's internal Raspberry Pi, meaning that the user would have to take the cover off and connect directly to it. There was no protective circuitry on any of the analog or digital sensor inputs. The software did not include any retransmission strategy, meaning that if the device lost connection to the cellular network, the data recorded during that time period would be lost. Upon implementation last summer, KWH personnel encountered an error with the communication command AT+CIP send, which prevented the unit from transmitting data from Zambia to the online server. Our project had 5 major goals. The first was to design a new custom enclosure with secure mounting locations for each internal component. Printed circuit board redesign to both match the new enclosure as well as incorporate new functionality. The software was to retransmit data if there's ever cell service lost, as well as resolve the AT+CIP send error. Finally, KWH also requested that the product be accompanied by product documentation to make it easy to use and reproducible.
I'll speak on the device's enclosure. This is our data logger. The enclosure was designed using ProtoCase Designer, which is a software tool developed by another one of our project sponsors, ProtoCase. ProtoCase makes custom electronics enclosures for products like ours, and they were generous to sponsor our project and donate 3 enclosures to us, which had a major impact on the fit and finish of the device, as well as our budget. On the front face, we decided to use Phoenix terminals for all the sensor connectors, as well as input power. You can see here full Raspberry Pi port access, as well as a female SMA connector for our antenna, and an on-off switch for the backup battery. Inside the enclosure, we have standoffs for all the electronic components to make sure everything has a secure footing. And on the cover, direct digital printing lets us put KWH branding so the device is easy to recognize, and we can also put labels on all the input sensors so it's easier to use. The footprint of the device is 200 by 150 and 60 millimeters, which is roughly the same volume as the previous iteration.
Moving on to the printed circuit board. This is the printed circuit board used by ECE 18.5, and this is the printed circuit board that we designed this year. As you can see, they're roughly the same footprint as to keep the space taken up inside of the enclosure minimal. On the screen is a layout of the previous printed circuit board design. Things to note here are that the new printed circuit board removed all of the onboard Phoenix terminals, which are now located on the exterior of the device. And the MAX 485 chip has been also removed. It previously served as the device's communication for Modbus. This is a layout of the current design. You might notice that there's a few more colors on here. That is because it uses a 4-layer board instead of a 2-layer board due to the added complexity of the trace placement. The things that we've added to the board are a 30-pin Molex header to replace the connections that were previously there for the Phoenix terminals. We've added hold-up capacitors around each significant power source to stabilize that. LM4040 voltage reference for the ADC, the analog digital converter, to give it a more stable 5 volts and improve the accuracy of our readings. Digital isolators on each of the 6 digital input pins to protect the PI from any overvoltage. Analog protection and potentiometers on each of the 8 analog input channels. The analog protection was done using fuses and Zener diodes, and the potentiometers on each channel serve to create a variable voltage division scheme so that the device can accept sensors with outputs anywhere from 5 to 30 volts.
I'll talk a little bit about our software. So software has 2 main goals. One is to store and retransmit data. That is important because these data logger is a part of the microgrid system in rural areas that don't have reliable signal connection. So we need a scheme to store and retransmit data. And the second goal is to overcome the transmission error mentioned before. So on here is the architecture of our database. So we used MySQL to build a database that consists of 3 tables: the config table, the data table, and the t-string table. So when we have input data coming in, these input data could be from sensors like temperature sensors, analog inputs from energy meters, and digital inputs sensors. When these input data come in, software will check the config table. The config table has the key, value, time created, time change, and active. The key is to mark what pin it is. So 8001 on here is analog input channel 1. The value 1 means we are using that pin. Time created and time change is self-explanatory. And active is to mark the most recent settings we have for this pin. So once software checks the config table, it will grab data from the input data and put it into the data table. And each input in the data table will have a timestamp associated with it. The value stored in the data table will be the actual value that the sensors input into our device. Software will then check in the config table again and grab all relevant data and put it into one string. This string will be then inputted into the t-string table. Each t-string will have an associated timestamp with it, and once the t-string is in this table, it is ready to be transmitted through our GSM module called SIM800L. So for our second goal, to overcome the transmission error, we have come up with the net strategy, and net strategy is a sequence of solutions that is embedded into a testing unit. These solutions include adding the IP header, switching between access technologies, changing the PDP type, and using SACIS3G. SACIS3G is an open source software that will let us bypass all AT command and will let us bypass the AT plus CAP send command that has issues.
Now we'll take a look at the results. Hardware integration was successful. We no longer have any loose components in the build. We've gained full Raspberry Pi access to the exterior of the device, so if you need to debug something in the field, you can easily hook up a monitor and keyboard without having to take things apart. The rigid steel enclosure combined with standoffs gives us a design that's better able to withstand transportation, and pairing a construction manual with our design makes it easy to reproduce for KWH personnel as well as future senior design teams. On testing, we were able to pair each one of our 18 system requirements, those are the SRs in this table, with an SVTP, which is the System Verification Test Procedure. Every system verification test procedure serves as a traceable document to ensure that our design met all the necessary requirements. And they come in 3 types: tests, inspections, and analyses.
For the net strategy results, we were lucky enough to have KWH personnel bring a testing unit to Zambia to test our solutions earlier in May, and we were able to receive the data on the server, and after we have analyzed the results, we have chosen to go with SACIS 3G as our main source to transmit data. For documentation, we have produced 4 different documentation. The first one, bill of materials, include all the components needed for a fully featured design, as well as a cost-effective design that includes only the bare minimum components to have it collect and transmit data. Beside the bill of material, we have the data sheet, the construction manual, and the user manual to make the project overall easier to use and reproducible.
We'll quickly talk about the project budget. The majority of our budget was spent toward project supplies. You can see we were able to save quite a bit of money there due to the generous sponsorship from Protocase, who provided the enclosures to us for free. Travel expenses for parking passes, so we could meet with our liaisons here on Seattle U Campus. And our miscellaneous expenses covered our data service plan, so we could test the device, as well as professional documentation printing.
So for our demo, we have turned on our device, and we already plugged in 3 different temperature sensors. You can see them up on here. So one is right directly on top of the battery of our system. One is in water, and one is just taking the temperature of the room. So up here is our sensor data.
Go back up.
At the top here, you can see there are 3 lines. The highest line is the temperature sensor that's directly on top of our battery. The lowest line is the one in the water, and the middle line is the temperature of the room.
We'll go ahead and switch to the next slide. We'd like to conclude by thanking everyone who made this project possible, including our liaisons, Dave, Alex, and Carrie, without whom we couldn't have done this project. We'd also like to thank our faculty and staff, Dr. Abraham, Dr. Louie, and Gary. Kirk, Kayla, and Steve were professional engineers who worked with us on various aspects of the project. And we'd like to give another thanks to Amy Hutchinson and Protocase for coordinating our sponsorship with that company. Of course, we'd like to thank the Seattle University Project Center for providing logistical, administrative, and working space support. That concludes our presentation. We'd love to answer any questions at this time. Yeah.
You had a slide on the shortcomings and you had component insecurity. Can you elaborate on that?
Sure. On the previous enclosure for the device, which was an off-the-shelf Jamico plastic enclosure, there were no standoffs that were customly placed for the electronics they needed to use. So some things didn't have a place to sit. There was a lot of glue holding things together. Some things would shake loose. So our design aimed to alleviate that by providing standoff mounting for everything that needed it, so nothing would shake around in transit or fall apart. And your second question?
Second question was the software side of it. Did you use model-based engineering on that, or was it just a testing result?
It's just testing. I'm not sure what you mean by model-based, but we have, so there are 2 goals with software. Are you asking about the net strategy one or the store and retransmit one?
Oh no, I just seen your picture there. It looked
Oh.
like it was model-based, so that's why I asked the question.
Oh, okay. That's the net strategy one. We just have a whole list of settings that we could change, and so we put it all in one software file, and we run it one by one to transmit the code that we marked for each solution. And the picture that you saw was not data, it's just like the code of the solutions.
So could you have automated it?
Yeah, it was automated. So the list of solutions gets run in sequence every time the unit's booted up.
Another way to ask the question I think he was driving at is, did you run a simulation of this using any one of the different simulation software suites
No.
to compare it against the actual?
Oh. No, so that solution is not to transmit data and to compare the actual data. That solution is to just overcome the transmission error to see that there are solutions that worked.
I noticed you don't have a cooling fan in there. Could you elaborate on the cooling aspects of
Sure.
the enclosure or the environment?
Yeah. So the environment these are deployed in can certainly get very hot. But the only real heat generating component inside is our backup battery, which is only going to be engaged if the unit comes off primary power. And it's not going to be drained and re-energized repeatedly in sequence. We would expect it to drain once and then be re-energized once. So we haven't encountered any thermal problems at this time. We have one of our data metrics is the temperature from the Raspberry Pi internal, and that's been well within the operating conditions for sustained tests. Yeah, Joe.
Did you ever figure out what the AT CPI send error was?
We didn't come to a conclusion for what exactly caused that error, but we're happy it's been resolved and we were able to transmit from Zambia.
Yeah, we put the actual initial code that the previous unit had on the testing sequence series of solutions, and it actually was able to transmit data.
That's life in Zambia.
Ghost in the machine.
Yeah. Okay, we are out of time, so let's thank So now there's a little bit of a break, and so stretch your legs, and we'll be back in room 110 for the rest of the ECE presentation.
He curves, he scores! Alex rolls on!
Hello, and thank you for taking a few minutes for me to share some important developments with you. There are big things happening on various fronts here at Seattle University this year. Let me start with the Center for Science and Innovation. I'm excited to share that we have surpassed an important fundraising threshold to move forward with construction of the center. A groundbreaking ceremony will take place at the end of May. This center is the biggest project in the university's 128-year history. It's where Jesuit education grounded in the humanities meets the future, giving our students a multitude of opportunities to advance in a technology-driven and continuously changing world. When completed, the center will become a forward-looking hub of creativity, learning, and knowledge that touches every undergraduate and many graduate students. As we look forward to the center's opening in the fall of 2021, we are grateful for the new partnership opportunities and recent multi-million-dollar support we have received for the center from global technology leaders Microsoft and Amazon, as well as the M.J. Murdoch Charitable Trust. This includes funding from Microsoft earmarked for programming related to the ethical implications of artificial intelligence. Now that's something right up our alley. Last year, we entered into a new partnership with Everspring, an online program manager, to help us move forward intentionally into online education. This effort will start in the fall with the launch of 2 online versions of Alber's business programs, the Professional MBA and the Masters in Business Analytics. The online programs will complement their classroom counterparts and allow us to reach a wider range of students in a way that aligns with our distinctively Jesuit education. Over the past months, many colleagues in areas across campus have been working diligently on a new student success strategy. Our shared calling to serve students the best we can is the driving force behind new initiatives we will begin implementing in the year ahead to ensure excellence everywhere across all areas of the campus. Speaking of gratitude, we are fortunate to have the energetic and engaging leadership of Provost Shane Martin for the university's academic enterprise. Shane brings a laser-sharp emphasis on placing students at the center of every decision of the university. I appreciate the many positive ways he is helping to lead the university forward when it comes to academics, mission, and shared governance. All the developments I have mentioned above are critical elements that will inform and shape the university's emerging strategic framework for the next 5 years. The strategic planning process, co-chaired by Professor Jen Marone and Vice Provost Bob DeLay, and led by a diverse steering committee, is underway and will develop its work in the coming months. The committee is moving forward thoughtfully and deliberately, committed to broad and deep engagement, and it recognizes a strong, inclusive process is just as important as the final outcomes. The new plan will set clear strategic priorities to guide the university in the next decade. Let me mention a few other important items. Last year brought to a conclusion our acclaimed Search for Meaning Book Festival. As higher education evolves, so must the university's commitment to bringing people together to explore the meaning and purpose of life from many diverse perspectives and voices. The vision for the festival now returns to the School of Theology and Ministry where it began, and it transitions into an ongoing speaker series and more. Along with regular podcasts and the continuing work of the Center for Religious Wisdom and World Affairs, the Search for Meaning Empowerment series will allow us to remain engaged with our broader community on these important ideas and thought-provoking topics that explore human meaning-making and purpose. This May 3rd to 4th, we are fortunate to again host the annual Crosscut Festival, organized and produced by leading regional public media organizations, Crosscut and KCTS 9 TV. The list of speakers and panelists is impressive and will cover a diverse range of big issues, policies, and ideas shaping society. This year's second annual festival will bring to campus 60+ speakers and more than 40 events. Confirmed speakers include former White House Senior Advisor Valerie Jarrett, former Cabinet Secretaries Christine Todd Whitman and Janet Napolitano, as well as top national journalists from the New York Times, Washington Post, and PBS NewsHour. Next fall, we will mark an important milestone with the public launch of Seattle University's Comprehensive Capital Campaign. Several kickoff events are being planned for September through November. These events will transition us away from the annual Fall Gala, which will be discontinued. We have already topped a record-setting $225 million in the leadership phase of the campaign, and we are very well positioned to reach our $275 million goal during the public phase. All of it is in support of our students through scholarships, the new Center for Science and Innovation, and other signature programs core to our mission. We are blessed to have so many generous donors. Planning beyond the campaign, the Board of Trustees in November approved moving forward on a comprehensive feasibility study for an event center on campus that could be the new home for our basketball and volleyball teams and, as importantly, a dynamic new venue for academic programming, conferences, commencements, and other signature university events and happenings. Look for more information to come as the task force completes its work on the feasibility phase in the coming months. Many big things are happening in the year ahead. Thank you for letting me update you about these developments and this year of significant change and transformation for Seattle University. Much of what I have mentioned will remain my focus as this summer I enter the remaining 2 years of my final term as president. We are intently focused on the future and charting a bold path forward into the next decade for our students and for Jesuit education. An education that prepares students not only for their careers, but for successful lives of purpose, meaning, and service to society. And I'm grateful to each of you who are making this possible.
There have been so many changes in the College of Science and Engineering. We've grown by over 50%. So STEM is becoming a much more popular field of study. Seattle is where it's at with software, and our students know that. We're innovating as industry innovates so that our students will be prepared for the jobs of the future.
CS 19.8, the Kenworth Fuel Tank Weld Repair Tracker. My name is Jonathan, and today I'm joined here by my teammates Patrick, Ryder, and Chaminade. I would also like to give a big thank you and shout out to our sponsors and advisors for this project. On the side of Kenworth and PACCAR, we have Sherry Sheeline, Scott Welch, Jason Hutchison, Blaze Reeder, and Alex Russell. On the side of Seattle University, we have our faculty advisor, Professor Mike Koenig. So without further ado, let's jump into our presentation. So in the fall, we were given the wonderful opportunity to work with Kenworth Trucks on this year-long project. And for those of you who may not be familiar with Kenworth, they are a global manufacturer of medium and heavy-duty sized trucks with offices based here in Kirkland, Washington. They are also one of the 3 major truck divisions under their parent company, PACCAR. Kenworth has a manufacturing plant located in Chillicothe, Ohio. In this plant, they take the fuel tanks that are found on their trucks and process them, checking them for any repairs that may be necessary. And with these repairs, if there are any that are necessary, their weld repairs are performed by either a robotic welder or a human welder. And with that information, it gets processed through their current fuel tank defect tracker Windows application, where they keep track of the tank number as well as what repairs were performed, who performed the repairs, and so on. To give you a little bit of more information about what their current fuel tank defect tracker looks like, we got a few screenshots of their current application just to give you an idea of what they are working with. And with that said, we had the great opportunity in the fall quarter to learn more about how Kenworth works on processing their fuel tanks in their manufacturing plant, as well as being challenged with this ability to work on migrating their Windows application that they were currently using to a web platform, so that would be more available to other manufacturing plants in the future. On top of that, there was also a challenge of adding some extra functionality to their existing web application. So one big thing that came out of our talks with them in the fall quarter was having a dashboard page. Managers really wanted to have a high-level visibility of what's going on in the manufacturing line and how all of their stations are performing. In addition to that, it was complemented with this cool admin page that allow managers to customize the application for their daily use. They can change when the shifts would start and end, as well as the particular goals that they would set for their manual welders or their robotic welders. And in addition to that, there were some other features that we added that weren't found in their current application, but now it is. And so now my teammate Xiaomei will talk more about designing our solution.
At the beginning of our project, we facing many challenges. Today I will talk to 2 challenges we facing. One is the UI design challenge. As a requirement, we focus on create a dashboard as a new feature to look how things going on in the daily life, which not included in the previous systems. What this dashboard look like, what the functionality is, we ask our questions. At the beginning project, we started with the wireframe to lay out the website before we do any coding. Another thing we have to accomplishment is new features, such as the search engine, and help user to navigate repair information. Another thing is we have added is repair information, and that also allows the user to add notes for the tank record. And another thing we add big thing is admin pages. So management can update their setting and add new users. Another big challenge is architecture design challenge. So this picture, we can see the data flow from your right side to left side. And this hierarchy structure. We use a model view controller and as a top layer to interact with the users through browsers. Then in conjunction with the servers and the repository design Panthera as the middle layer. The bottom layer is connected with the Kenworth database. Through this design Panthera, our code will be easy to more readable and easy to testing. Another thing I want to introduce yours is we use technology for this project. As a requirement, we use the Microsoft product for this project. So we use ASP.NET, C# through Microsoft Visual Studio as development tools. We also use Microsoft SQL Server's management to manage our database. As you know, we can code up our web pages through HTML, CSS. Beyond that, we also use Bootstrap's framework to develop responsible web pages. In our project, we often use JavaScript, JSON, and JS, which are boundless for our project. So wait, you will see our demo for this web page. Really update the user to let the user to easily use and navigate information. Last not least, we use Google Drive, Slack, and GitHub to collaborate our team member and communicate each other. So through this project, our team, we have wonderful experience as a development team. Next, Router will talk about us development process.
Perfect. Let me take you guys through the development process we went through this year. Back in January, we started implementing the application. And immediately, we established weekly meetings with our business stakeholders to use the Agile methodology, something that we really weren't too excited about. It was a lot of meetings. We felt like fish out of water in a professional environment. But we did it because our advisors and stakeholders insisted on it. And a few weeks in, we started feeling confident in our meetings. We felt good about our presentations and that we were delivering well. And give us a few more weeks, and we felt connected with our stakeholders, such that if we missed a meeting, we were actually a little bit sad that we didn't get to connect with them, especially the guys in Ohio, because we did a lot of meetings with them. And so we'd like to share with all the other teams that it's important to really trust in the Agile methodology. It's something we learned this year, and it really helps the project move along and add value. So the next thing we went through was code reviews. This is on the technical side. About halfway through the winter quarter, Sherry Sheeline connected us with Alex Russell, a software engineer at Kenworth. And in these meetings, we would show off our code. We'd collaborate on the next problem we were having on the technical side and kind of discuss what was going on in the back end. In these meetings, we weren't terribly good at communicating technical ideas at first. We'd confuse ourselves. We'd confuse Alex. It was a big mess. But Alex was always patient with us. He'd answer our questions. He'd take time out of his own day to make us example projects to demonstrate key concepts in the next part of our development. One of the first challenges he gave us was dependency injection, and in this process we had to do a 2-week project of refactoring our code, just completely restructuring the project. But it really wasn't too hard because Alex was this blessing for us, this second advisor. So we would come to him early in the week and we get his perspective. Later on we come to Mike and he'd give us another perspective. And with twice the mentors, we had twice the fun, first of all, and we also felt twice as comfortable and twice as capable by the end of the project. And the last thing we want to share with you was the challenge of balancing these two groups, so the technical side and the business side. Both of these kinds of meeting, the Agile and code reviews, were happening at the same time. So every week we had to deliver something to Alex, and we had to deliver something to the business people. And this was a bit of a challenge because the project already felt like the biggest thing we'd ever handled in our coding careers. So it was difficult to manage our times, and we had to be very intentional about delegating our tasks. One of the things we had to do was right at the end, we were implementing the database, and we come across a new feature that the business people want, adding kind of a new category of especially difficult repairs. So we're working back and forth, and it's this kind of complicated mess for us to handle what's going on. But we learned to be good team members and communicate well. This is something that groups should look to establish when they start their projects next year in the future. The faster you can develop teamwork and establish good lines of communications, the better you'll do. So we think we've made an application that both we can be proud of and Kenworth can be proud of, and Patrick here will show you a demo.
Awesome. All right, I'm super excited to show you our 9 months of hard work and what it looks like. So I'm going to be walking us through our 4 main feature sets. That's going to be the new dashboard that shows metrics, an admin panel, which at first we didn't know we needed, but building out the dashboard, we realized there was going to need to be some customization. Also our search function, as well as an add tank record function as well, which is really the bread and butter for the operators. So first, let's say I'm a day shift manager and I'm just settling in for the day. So I can open up the application and go straight to the day section of the dashboard by clicking that day tab. Right away on the left-hand side, I can see how my manual operators are performing, and then also my robot operators. So I can see the tank throughput for both of them. And then I can see a breakdown from the station level. So right off the bat here, I'm looking at all my different stations, and I see that there's 14 repairs done thus far for Station 1. And as a manager, that's really important because the shift's just getting started. That might be something I want to follow up with and check with the team that's at Station 1 and see what's going on. Is it a bad batch of tanks or what have you? Something to look into. So that's great information for them. Next, as a manager, I'm actually need to make some changes to the dashboard and the overall system. So I'm going to go to my admin panel. This is something only managers have access to. Today, the day shift is working overtime, so there's some changes I have to make. First, increase the shift time, so the end date, we're going to bump that up an hour so we can make sure we calculate the pace correctly on the dashboard. And then also, I'm going to increase the tank throughput goal for the day shift by increasing it by 2. So we can reflect that and see if our shifts were able to, or our stations were able to make that within that extra hour. Some other information I have as a day shift manager is we had a robot operator that was offline and needed some repair. We actually just fixed it, and we want to put that station back online with the robot operator, so I can make that change from the admin panel, and now it's an operator station, and we can track those metrics from the dashboard. Additionally, as a manager or a welder, I can search for a specific tank. In this case, I'm a manager. I want to see all the tanks that have been processed thus far today. So I go to my search function. I'll put in today's date, and I'll be able to see how all the different tanks that have come in thus far and see if there's any discrepancies from that page. Sweet. So right off the bat, I see all the tanks that have come through today, some basic information, and I can actually click in and view. I see that the second tank there has 3 repairs. That's something that catches my eye. I want to go in and see what's really going on. So I'll click on the details, scroll down to the bottom, and here's all the information, including we can see exactly where repairs exist for that specific tank, and they're color-coded so I know exactly what kind of repair it was. I want to actually update this tank record now, which is a new feature that you weren't able to do before. You couldn't update any information. I want to leave a new repair note and just let my other managers and myself know I'm going to follow up about this tank later. So I'll put that information in the repair note, and I can save that directly back to that specific tank record. Great. So that's kind of how we see the manager using the system and talking with our business stakeholders. But now the bread and butter, as an operator, I'm going to be adding tanks from my station. So the add page. Here is where I can enter all my information. I begin by entering my operator number, what station I'm at. I'm operating at Station 1 currently. What the tank number that I have that I'm currently working on is. As well as the sequence number, which it represents the batch of tanks. So multiple tanks have the same sequence number, and it's in concordance with the specific set that they came with. So that's important to track. The tank size, what side my robot operated on, where the drain location is, what kind of tank it is. And now I am looking at the tank, and I see that there's a couple scratches on the left-hand side. And so I can go ahead and select the scratch, and I can point out exactly where they are in the bottom left and mark those. And then I also see a leak on the right-hand side of the tank. So I'll switch my specific repair I want to check, and mark that as well. And that'll be great because that'll save for other operators and managers that want to fuel that tank. I can mark my repair time. This repair took 4 minutes, which is great. This is a new feature that wasn't able to be tracked before, so now managers can see how long tanks take to repair. As well as a repair note, I want to let them know that the scratch was 5 inches wide on the left side, just so we're kind of watching scratches closely on this shift, so that's something I want to leave for my managers. And I can see that the tallies have all been added up for those specific repairs. So I can click save, and then I'm ready to record my next tank that comes through. So yeah, super exciting. That we're really excited to have that application go out to those employees at the Ohio manufacturing plant. And kind of next steps for us, hand the project over to Kenworth, obviously. We're super excited. This is something that, you know, the Ohio manufacturing plant employees are going to be using. I know that a lot of capstones hope for that and say that, but you know, there's talks about within the next month this being implemented for them, and even talks about it going live for AWS, one of their first applications to ever go on AWS, just because it's new to the environment. It would be a really good test case for that. So that's super exciting too. And in conclusion, this has just been a huge learning experience, invaluable learning experience for all of us. I think from the beginning, a big thank you to Sherry for making us kind of stick with that Agile process, and we really got to learn how important that process was and how it did churn out results, and that was really huge. And then also being able to work with Alex Russell was huge for us because it taught us how to implement professional software patterns, which, you know, that's the whole point of Capstone, I think. And so the fact that we got to work with someone that was willing to really mentor us through that process and kind of learn how Kenworth specifically, you know, handled their data with a dependency injection. You know, not all companies are going to do that, but to know that there's a specific way within corporations and how do we go about that process when we're building on an application was a really valuable experience. And I think something we'll all take with us into the rest of our careers. And then obviously, learning how to communicate. That's number one thing, I think. You know, at school we sit here and we code, but then once we go out into the real world, we're going to have to be able to explain our ideas to people and what exactly we're doing. And so to be able to have that experience, work with business stakeholders, and like Ryder was saying, explain our technical ideas to technical stakeholders is a really important thing as well. So we're really glad to have had that experience. We've had a blast working together this year and with Mike as well. And we just thank you all for coming along the process with us. And as always, remember, keep on trucking.
Do we have any questions from the crowd?
Yeah, what kind of documentation are you providing for the software?
We have commenting throughout. There's a couple really tricky functions, especially to do with the database. We've made a change script for the database changes we've made, and we're going to draw up maybe a document explaining some of the tricky bits. We've also been in such close contact with Alex. He kind of knows what's going on, which is a great blessing for us. Yeah. All right.
Given more time, what additional features do you see being added to this app?
There are a few filter functions that were asked for, but were a little bit tricky with the time constraints. I think operators wanted one that would be scrap-free tanks. We got the engineering issue, which is the bigger repair kind of category, but as it stands, there's no way to directly search for that. There's only a way to search for how many of each tank there are. And I think there are a few things in the old app where they have a few subtle differences in what metrics they show, and that's something that would be easy to add on. It just didn't come together for us.
On the screen that the operator puts the information in, do you know, is that like an inspector that identifies all the defects and then the manual welder goes through, or is it the manual welder who does it and then goes and fixes it?
As we understand it, there's one person that receives the tank and works on it, and then the person who's handling entering the information is a different person who will be doing this. And they have like a scanner to do most of the information, and they manually put on the rest. All right, and if that's all, we're good to go. Thanks for listening.
Thank you so much. Thank you.
Put this in your pocket. Put this on.
just right here.
Oh, really?
That's what Koenig said.
Yeah.
If you want to. Okay, cool. We are CS199. We worked with Kenworth on their supplier collaboration system. On the next slide. Today, we are going to talk about a little bit of the background of the project and then get into the main features that we made, as well as going to a demo and then looking to the future for what's next. I am Rose. This is Jared and Ian and Duke. Our faculty advisor was Professor Mike Koenig. The sponsors that we worked with at Kenworth, they were Walt Brewer and Evan Winter and Ramji Gupta. They were our main contacts throughout this process, and they were very helpful on giving us guidance and mentorship throughout this whole thing. We also had Nick and Melinda, who got us set up with our accounts and our laptops to get us started on this project. And then we had Pravin, who was our offshore developer, who helped us learn more about ThingWorx, the tool that we use to build this project. So a little bit of background about this project before we get started. Kenworth builds trucks, and there are a lot of different parts that go into those trucks because they're all custom and made to order. So managing the changes to the parts that go into these is extremely important and is a system that's used by the engineers and the suppliers all the time. The interface to manage these needed an update, and that's what we were tasked to do. We were tasked to make it simpler for the engineers and suppliers to enter information and faster for them to get through, as well as to simplify the process so that the process does not stall by having different parts that the user has to navigate through. By condensing it all into one, we made this process simpler for them to use.
All right, so for our task in revamping and improving the overall system interface for the supplier collaboration system, we decided to break it down into 3 parts. So the first part is the change request creation task. So as the system is currently deployed right now, the whole task consists of a total of 9 pages. So each of those pages are designed kind of like as a wizard-like form, where the user would need to step through each of the pages in order to initiate or start a change request. So our obvious goal initially was to reduce those pages to as few as we can. And through collaboration with the Kenworth engineers as well as the users of the system, and them giving us their feedback with the current system as it is right now, we have been able to reduce the total form into 1 page. And we did that by only displaying the correct or valid fields for the type of change request that the user is trying to do, i.e. a deviation request or a generic change request. We've also added, another problem that we have identified in the change request creation is associated with the files that are relevant to the change request, i.e. a engineering drawing or images or any other kind of files that would be pertinent to that request. One of the problems was the users were able to link or provide a hyperlink for the files for reference when they go into the review process for the change request. And one big problem with this was that often the linked files would be removed or renamed or like totally move into another file path in the file system. So in turn, when the review process comes in, there would be a lot of frustration or confusion for the review team because they can't find the files and now they have to go hunt for it. So we have solved that problem by removing the hyperlinking feature entirely and only allowing the users to upload the files manually to the change request as they create it. This would in turn make the files stick with the change request object throughout the whole lifespan, so the users won't have any problems reviewing it. So the second part in the system is the manage participants task. Currently in the system, this is separate from the change request creation task as well as the approvals task. So one opportunity that we have identified was why can't we just include this separate task into the change request creation task as well as one of the approver tasks, which is the peer review. So we've done that by incorporating it first in the change request task, all within the same page, and the users are able to do that within the task. And we think that this is just a better workflow overall for the users because it kind of makes sense that way to not separate this task from the other ones. Another feature that we've added was the reactive and intelligent buttons for the actions in the task. So these buttons would automatically enable or disable themselves based on what the step in the task the user is doing, i.e. removing or modifying or deleting a user in the review team for the change request. And finally, we decided to add visual validation for the task so that the users can conveniently see as they go through the task that all the roles in the review team are being populated correctly before they go ahead and finish the task. So this would eliminate potential confusions as new users would be using this. So lastly, for our division for the task is the approval task. This is essentially the last step in the change request lifecycle. And typically, there are around 100 change requests that needs to be managed by the review team each week or at any given time. So this is basically where users spend most of their time, either reviewing, rejecting, approving the change requests as they go about in their days. So one of the, actually, there wasn't any things that we identified that we can reduce in this system or in this task. We thought that it was already good enough, so we have decided to improve it visually, and it allowed us to put some error validation or input validation for the users as they go about in the task. So pertaining to the user validation, a use case scenario would be when a user or a reviewer in the review team is trying to review or reject a line item associated with a change request. Before they would go ahead and finish that task, they would be required to input some informative comments so that the whole review team would understand why this specific line item is rejected or is put back into rework. We thought that this would make for a better communication for the whole review team as they go and review all the change requests. And then for the visual improvements that we've done, we have provided some summary status reports for the task, i.e. the current status of the change request, as well as the individual statuses of the line items, all conveniently placed within the view task. So all in all, putting it all together, we have identified some problems in the current system, some efficiency problems, and we were able to significantly reduce those in both the managed participants task as well as the change request task. And then we've also improved the approvals task by providing convenient visual feedbacks for the users, as well as enforcing strict business rules for the users as they review each change request. And we have gotten feedback from Evan Winter, I believe it was last week, and with these current changes, the current system would be approximately 45% more efficient, resulting into around 21 plus business hours for the engineers as they use the system, pertaining to data entry alone. And as a team, overall, we think that this would make for a more efficient and better workflow, as well as generally improved user experience for the users that are using it.
So now we have talked about our achievement over the year. For today, we'd like to demo 2 pages in our system. So let me start with the change request creation page. So assuming I'm an engineer in Kenworth, so today I would like to make a deviation request. So just go ahead and go to the change type and choose the deviation request. So for the deviation request, I need to add extra information. So it's very convenient on the right-hand side over here. Just go ahead and populating that data. So deviation category, dimensional. So I want to fix the headlight, and the end date is going to be a week from today, so 14. And the plans that affected by my deviation request was all the plans that Kenworth have. Okay, and after I finish populating the data for deviation request, I want to add the files for my deviation request. So I just go over here, add local file, choose files for my computer. Let's say I want to add this picture to my change request, upload. So if I want to check if the file was already attached to my deviation request, I just go over to this grid and check for the name of the file, and it's there, capture.png. Next, for the change request, I need to add the line items. So we go down over here. Due to the time constraint, we already pre-populate some line items information. So one change request can consist of multiple items. So user can either add more items over here or remove them. And the very last step I need to do is I need to add participants to my change request. So there are 7 different rows here. Each row will need at least 1 participant. So let me just go ahead and add people for the participant. So for the approval 1, I want to add Bill Bryan to be my approval 1 reviewer. And for the approval 2, there are quite a lot of people over here. Let's say I want to search for Zoe, because we're very close to him. And Zoe Smith here, I'm going to add him to approval 2. And next, I'm going to add 1 more person for dimensional management, Austin. Okay, so let me try to submit the form right now to see what happened. So the system doesn't allow me to submit the form because required field haven't been completed. And it's show me what field do I need to do. So I just go ahead and add the deviation is going to be Kenworth, and suppliers, say Kenworth. And the location, I say Renton. And as you can see over here, there are 4 more rows need participants. So I just, okay, I'm going to start populating the rest people. Purchasing is going to be John Lee. Safety and compliance. And the supplier. So now all the roles are already be occupied by reviewers. So I can safely go ahead and save my change request, and it says save successfully. There's no error. And the next page we would like to demo is the approval 1 page. So remember when I add people for the add participant for 7 different roles, so approval 1 is one of these. So for this page, I want to first reviewing and working with each individual item, whether I approve, reject, or rework this like individual item. So the default status is approved, as you can see over here. And let's say I want to reject the item 3, the very first one. Let's just click reject, and I click update. And I cannot update because I forget to put in the comment, and I have to put in a comment. Reject because of its old drawing. So it's and same to rework. Let's say I want to rework the item 5. I need to put a comment as well. So it's also have the very old drawing, and I'm looking for the new drawing, and it has to be reapproved by me. Update it, and we can see over here the overall status is rework. So every time I change 1 item, the overall status is going to get updated, and it's kind of convenient for me to see. And when I finish working with all the items, I gonna try. So for this change request, let's say I want to add 2 more review for this change request. So dimensional management review and safety and compliance review. So, and then I just write a comment. Because the status rework, I just try to make sure it can rework. And I complete my task. And yes. So if I want to check if my task is already successfully completed, I just go down to the additional information and see over here, all the data is going to be shown in this grid. So approval 1 is finished, and the vote is rework. The comment is, I just put in rework as well, and the date I finished my task. And 2 more review tasks going to be added to the grid, dimensional review and safety and compliance review. So that's it for our demo today. Now I will hand over to Ian for the next section.
All right. So, what's next for the future of the project? Well, once we hand off our pages to the Kenworth devs, the next steps is to build a back-end connection to the Windchill servers of the live database. Once that's done, the only thing left is the data connectors to be implemented so that our pages can read the data objects from the live database and update them so that our pages can actually be interfaced through the system. Once that's done and the final code review is complete, they're ready for deployment. And we're very excited to wrap up and hand this off to the Kenworth devs. Well, we've learned quite a bit throughout this year, and we very much appreciate all the help and guidance that was given to us by everyone at Kenworth and here at Seattle U. ThingWorx was a relatively new technology to Kenworth, so our team had the unique opportunity to be one of the first groups to really dive into the system and learn it, which presented its own challenges. But we overcame those by getting in contact with an offshore dev, as Rose mentioned earlier, Pravin, and he was very generous with his time with us. And so with our back and forth meetings with him, we got a good grasp on the development environment. Once that was completed, we dove into the Agile process and got set up with weekly meetings with our sponsors at Kenworth. And through the Agile process, we were able to track goals, meet deadlines, and show weekly progress and iterate on those ideas based on feedback from our Kenworth sponsors. We put a lot of hard work into this, and we're very, very proud of what we did. And we're excited to see it deployed in the Kenworth servers. Once again, we want to thank everybody from Kenworth, Walt Brewer, Ramji Gupta, Evan Winter, Nick Cran, and Linda Martin. And a big shout out to our offshore dev, Pravin, where he was again very generous with his time with us. And of course, our faculty sponsor, Mike Koenig, who was very helpful and overall, and most of all, patient with us as we got our foothold in this whole crazy process. Are there any questions?
Can you explain a little more about ThinkWorks and how you integrated and what that is? I'm a little confused by your underlying architecture.
So the current framework for the system in place is the Windchill, and ThingWorx is a more of a graphical user interface development environment for that, and it is built by the same company, so there's some similar interfaces. And Kenworth recently got a hold of the ThingWorx technology because it's a better user interface development environment. So it's relatively new, but it has the same background and framework, so it's relatively easy to interface with the current Windchill system.
Can you talk about what you were migrating from and what kind of environment technology was involved there?
Yeah, so basically it's the same stack for ThingWorx. The stack is from PTC, a company called PTC. So the old system was built on the old one, which is Windchill, which was basically concerned with the back end, and they just kind of like built that on top of it. ThingWorx is this new technology that PTC is rolling out, where it's mainly focused on the UI aspect or the front end aspect of the system. So that's what we were basically tasked to build the new system on.
All right. Thank you very much.
Jackie?
I got it.
We're software engineers, but these are a little difficult.
Good afternoon, everyone. Thank you for attending our presentation today. We are Team CF1911, and the title of our project that we've been working on is PACCAR Industry 4.0 Knowledge Sharing. So to provide an outline of the project presentation, we will begin with our team introduction and provide a background about PACCAR and an overview of the project. We'll then go into detail about the user requirements, design, and approach that was taken to do the project. We'll then transition into doing our demo and then wrap up our presentation with the conclusion. So for our team introduction, our sponsor that we've been working with for this project is Mr. Ken Faith, who is the Assistant Director of Supplier Quality at PACCAR. Our faculty advisor is Professor McKee. And my teammates who are joining me here today are Keegan Fisher, Cynthia Shea, Christopher Ross. My name is Jackie Wong, and also a student who has been helping us during this project is Alie. Alie has been helping us with the deployment documentation, and we would like to thank her for all of the help that she has been providing us.
So to give a little background about PACCAR, PACCAR is a global technology leader in the design, manufacture, and customer support of high-quality light, medium, and heavy-duty trucks under DAF, Kenworth, and Peterbilt nameplates. And one of PACCAR's quality pillar is best practice sharing. And over the years, PACCAR has benchmarked all types of improvements, identified best practices, standardized best practices, and implement them across all plants. Currently, best practices are not consolidated into a single location or formatted in a way to accelerate best practice sharing among plants and suppliers. So for this project, we were given the opportunity to help improve how information on best practices is managed and help help PACCAR come up with a process that can
Yeah, so just to go off of that, to also help PACCAR establish a process to denote best practices once they've been read across locations.
All right, so when we started this project, we had to kind of figure out what it actually meant to have best practices and consolidate them and collect them. So what we did is we connected these things called voice of the customer interviews. And what we did is we interviewed a bunch of different employees from the supply team and kind of like asked them what the difficulties that they were having are, how long it was taking them to find information, and how we can make this look better. So it was taking them anywhere from 15 to 20 minutes on average, but sometimes even much longer than that. And in order for PACCAR to verify that standards were being followed, it would take anywhere from $3,000 to $4,000 for them to send someone out, do a verification of the site. So we wanted to make sure that we could figure out how to make the situation better. So the takeaway from this was that we need to have everything consolidated in one location. They wanted something that looked like Google so that they can just type something into a search bar, find results, and not be inundated with an excess of information. They wanted only the results that apply to what they're looking for. So we are hoping that through this project in the application that we've created, that we can have a central location where they find these things, and that's going to prevent defects from getting sent out the door and reducing overhead.
So from the interviews with our sponsor and stakeholders, we compiled a list of user requirements for this project. And as you can see, the bolded requirements are the ones that were implemented in this project, including metadata to denote which best practices should be standard and when the standards have been read across our other locations. And after this project is handed off, the application will undergo continuous development where addition of features and functionality will be implemented.
All right, now to go over the frameworks that make up our application. For the front end, we used a single-page application architecture, which was powered by Vue.js and Quasar front-end framework, which pairs great with Vue.js. And for the server side, we use .NET Core for the RESTful API services, paired with Entity Framework Core, which is a object relational mapper for the database that we were using, which ultimately ended up as Amazon Aurora RDS. And the web application is hosted with Amazon Web Services. And the search functionality is powered by Apache Lucene.net. And we were targeting cross-platform mobile devices. So we have an iPhone up there, but really we targeted a whole plethora of operating systems. And Solar is an enterprise search platform which is powered by Apache Lucene.net. And some of the major features included are indexing, hit highlighting, and just really allowing us to power our application with very customizable searches.
All right, so this is a kind of basic physical diagram. There's a lot going on up there, but essentially what we have at the very top is we wanted a pipeline created so that we could have things compiling every time we committed to master. And this pushes it directly into the AWS cloud. We had to integrate a lot of different services within AWS, and this was definitely a big challenge for us to make sure everything was talking properly. But in fact, by implementing so many services, it actually created a lot of things to be easier for us to implement. So this isn't going to be the way that we recommend that PACCAR goes on to implement themselves, because they'll have much more resources that will kind of streamline that process for them. And now this is just more of the simplified logical diagram of the components that we actually care about. So CloudFront is just a content delivery network service that AWS provides. And this basically prevents cross-origin errors that we were having initially when we tried to implement. And so this is going to connect the front and back end together so it looks like they're talking from the same domain. And then one kind of annoying feature of the Aurora database system is you can't access it from the internet, so you actually have to connect to an EC2 instance in order to communicate and manage it. So that kind of sums that up.
So now to transition to the approach that we took when doing this project. In the fall quarter, we spent most of the time gathering requirements. Besides the voice of the customer interview sessions that were previously mentioned, the team also had the opportunity to visit the Kenworth Renton plant, and this is just a photo that was taken during our time there. When we were there, we had the opportunity to tour the facility, and we also had the chance to meet with Ken and a stakeholder named Brian to further talk about what features and functionality would be included in our application called PACCAR Best Practices. And so just the voice of customer interview sessions and the meetings that we had helped us gather and formulate the requirements for this project.
Over the winter quarter, we decided on the frameworks that would make up our application, and those ultimately were the frameworks that I had went over on one of the previous slides. At this point in development, we were using Azure Web Services for hosting our web application and continuous integration. And most of the time that was spent in this quarter was really just familiarizing ourselves with technologies that we hadn't previously encountered.
So like Keegan was saying, we initially had everything on Azure Web Services, and we spoke with PACCAR IT, and we got some new direction, and that was that we wanted everything on AWS. So we had to do a complete migration from the Azure framework over into the AWS infrastructure, which took a lot of time and actually held up development for about almost 2 weeks. So that was probably a big blocker in the development this quarter. In addition to that, they also wanted to have a containerized application for the backend, so we went ahead and did that for them while we were in the middle of that. So we continue to extend the functionality of this application all the way up until the end, and we're hoping that there's still features left to be developed. But the thing that's really cool about this is we've helped kind of think about the process that will be going through in developing these best practices for making sure that they are read across the multiple sites, and it's going to be extensible and scalable as it moves into the future.
All right, and now we'll do a quick demo of the application, which you can follow along with on your phone, but it's quite the URL there. All right, So we're going to go in and upload a best practice. I'll just title it Projects Day Best Practice. And we've got a summary field here to summarize what the best practice is. Whatever. We've got a list of companies here to choose from, which are all under the PACCAR umbrella. I'm going to go with PACCAR there. And a few departments as well. All of these fields are indexed by solar, so they are all able to be searched on, all different fields. And we also have filters that allow you to do that. And I'll just fill in some more information here. Some keywords, which users are able to expand upon as well. And I will upload a file, which I have conveniently right there. We'll submit. And this is just a landing page, a view page. And you are able to download all of the information. Right now, the best practice is just in JSON format, which is easy for the user to read. And the other files are able to be opened. And now we can go to the search, and we can search for Projects Day. And there it is right there. And that search is powered by Solar, which is very customizable and very quick. And that's about it. That's all I really wanted to show you right now. How do we get back? And these are just some stock photos in case that's the direction we wanted to go. There we go.
All right, so for the conclusion of our presentation, one of the lessons that we learned was the importance of documentation, since that is what the project will be based off of, and that it's very important that time is taken to document in detail all the requirements and specifications of the project, and to take the time for careful review of all of its content, and to make sure that that content is agreed upon by all parties so that everyone is on the same page about what the project is about and the expectations for it. Regarding the project turnover, this application will undergo continuous development after it is handed off. And the good thing about that is that it will be an opportunity for PACCAR and suppliers to use a product that will help them save company resources while also delivering premium services to its customers. And by implementing PACCAR best practices globally, that will help PACCAR further continue to strive to make their products with zero defects, and to continue to further strengthen their presence as a global technology company. And so that just summarizes the value of this web application. And finally, to conclude, we would like to thank our faculty advisor, Professor McKee, for all of the help that he has provided. And we would also like to give a big thank you to our sponsor, Ken Faith. Ken, thank you for all of the support that you have given us throughout the project, and we greatly appreciate your time and support and involvement in helping us with this whole thing. We would also like to thank everybody at PACCAR who helped us along the way as well, and we greatly appreciate their support and involvement with everything that we've been doing. And we're all grateful for the opportunity to have collaborated with PACCAR on this project, and we wish PACCAR the very best moving forward in the future. Thank you.
Any questions?
Professor Mon.
So all of the tagging, all the tagging is done by the end user, or do you actually have tools within Solar or other products that help create tags to search for later?
Yeah, so that's really handled by the server, the back end, that handles all the tagging based off of the various inputs that they attach with the best practice. We all of those fields are indexed within Solar, and then also we scrape all of the text from whatever file that the user attaches to a best practice, and that's also searchable. So yeah, that's handled on the server side.
A very good presentation. I enjoyed it. Can you talk a little bit about the issues you found from Azure to AWS porting?
Sure. So I felt that the way that Azure was set up is when you went through the process of sending the application up into Azure, it kind of just gave you everything that you need as you went. We even had this beautiful URL that Azure gave you that went really nice, because when we did this presentation in front of the vice president of global quality, she was able to type it in on her phone and play around with it. Typing in D28B isn't as nice, but hey, that's not the worst thing in the world. But it got worse when you got into migrating the Microsoft SQL database over to the Aurora MySQL. There were things that didn't play nice. We had to go through and rework a lot of the database. And just component-wise, I think if you saw the physical diagram, just the amount of components I had to figure out what this thing was, what it did, how I need to make it work with the 5 other things that it needs. It was just a huge jigsaw puzzle, and it took well over 48 hours of my time. Hope that answers it.
Anything else?
It's a pretty cool presentation. I liked it. One thing that I had a question about is, do you have a pre-existing database of best practices that you could use to prime this with to give it a bit of a hot start, or is the plan to like build it from the ground up?
So really, we're building it from the ground up. Previously, PACCAR was using a SharePoint server, and it was just too hectic and to get all of those best practices, because there were so many different SharePoint servers, and the structure of them wasn't consistent across the SharePoint servers. So we were really tasked with just building something from the ground up and not worrying about any of that. All right. Thank you very much.
Thank you.
Download your expensive tech.
What if we could increase the chances, tip the odds for all our kids? Seattle, rich in so many ways, also is home to a staggering amount of people without great access to opportunity.
On any given day, between 50 and 70 students at Bailey Gatzer Elementary School are homeless.
And 1 out of every 3 people in the neighborhood is living in poverty.
We can change that. The Seattle University Youth Initiative was born to change that.
The community needs what the university can offer.
And the university needs what the community can offer.
Each year, more than 1,000 Seattle University students dramatically broaden their life experience, and the community gains new access and inspiration.
But it can't stop there, because what happens before school
and after school is equally as important.
Families need access to affordable housing, high-quality healthcare, and living wage jobs that empower the entire community.
And college students need to be challenged to see injustice and participate in meaningful ways that shape themselves and the community around them.
Seattle University Youth Initiative is a coalition of dozens
and dozens
and dozens of existing programs that support the community.
From housing, food, job training, counseling, and after-school programs
that open up the entire world to kids who may not otherwise know they can be scientists,
filmmakers,
professors,
entrepreneurs,
and political leaders.
Surrounded by community, surrounded by role models, surrounded by support, surrounded by scholarship opportunities. For those who achieve, everything is possible.
As the community benefits and the university benefits,
new leaders emerge
in business, education, health, and social justice.
These young citizens, equipped for success, transform our city and perhaps even our country.
Seattle University Youth Initiative, where preparation meets opportunity.
Today we're going to take a closer look at electricity. Electricity is a natural force that we harvest for our energy needs. To understand the basics about electricity, we need to learn a little more about atoms, the tiny particles that make up our universe. 3 smaller particles make up atoms: protons, neutrons, and electrons. Electrons have a negative charge, protons have a positive charge, and neutrons are neutral. The center of the atom includes protons and neutrons, while the electrons orbit the center like the Earth orbits the Sun. Why are electrons flying about orbiting the center? Electrons, protons, and neutrons are made up of even more smaller particles. Electrons are made up of elementary particles called leptons, while protons and neutrons are made up of elementary particles called quarks. Quarks feel a force that leptons do not. This strong force binds protons and neutrons together, creating a center nucleus, while the electrons do not feel the force and continue to orbit. Electrons closer to the nucleus feel a much stronger attraction to the center than those in distant orbits. The outermost electrons require the least amount of force to be freed from the atom. In atoms, if there are more electrons than protons, the atom has a negative charge. If there are more protons than electrons, the atom has a positive charge. An electric charge difference creates an electric potential difference that can be measured in voltage. If an atom has an equal number of protons and electrons, its net charge is 0, or 0 volts. Volts measures the pressure or force of electricity and is required to make electrons flow. A voltage of 0 creates no electron movement. If the potential difference is great enough, electrons flow. A material such as plastic or rubber may hold on to its electrons more tightly, meaning the electrons may be orbiting closer. This is known as an insulator. If the electrons are more loosely bound, this is known as a conductor, such as a metal wire. When the voltage pressure is large enough, the freed electrons push each other out of their orbits, jumping from atom to atom through the conductor, creating electrical current flow. The rate of the flow is measured in amps. The electrical current is composed of flowing electrons passing from atom to atom through the conductive material. It is this form of electricity that powers our homes. My name is Peter Karaoke.
The Muru Bay Microgrid project is really an energy kiosk.
Providing power to a rural area in Kenya, specifically Muru Bay.
There's no light after around 5 p.m. because they're really close to the equator, so typical day and night are pretty equal.
They have to rely on kerosene lamps, and these kerosene lamps are they're expensive, they're toxic, and they're really dangerous.
For the last 7 years, Seattle University has been doing humanitarian engineering projects as part of the Engineering Project Center.
We found a bunch of donors, primarily the Alstom Foundation for the Environment, along with a few others.
There was a team of electrical engineering students who spent all of their senior year working on the design of this microgrid.
About 20 plus professionals from the Seattle area.
2 wind turbines and 2 large solar panels to provide the energy for these 70 battery kits that are being charged at the energy kiosk.
The people in the community, what they do is they can take their cell phones and they can bring it to the kiosk to be recharged for a small fee. And they can also rent portable battery kits, which are batteries that come in a ruggedized case that let them plug in lights. And so they can bring it home to their house and they can have electric light in their home for the first time at night. And it's amazing to walk around the community and see electric lights at night.
Seattle U's mission is, for social justice. That's a part of their missions.
We don't want to just train our students to go out there and find jobs. We really want to empower them to change the world and be leaders. And I think there's no better way of doing that than going out there and serving the underserved.
Being born and raised in Seattle, but my family's originally from Pakistan, I've seen the differences of lifestyle. That's one of the reasons why I went into electrical engineering, was to provide lighting for people in need, because light makes a huge difference.
We receive data on how the system is doing it once a minute, believe it or not. That's sent to a web page that can be viewed by anyone, anywhere in the world if they want to know how the project is going. And it's such a wonderful asset to have, and it makes the project seem real. Whenever I travel to a developing community, I come back a slightly different person.
Well, just the experience as a whole is just kind of undescribable.
It feels very fulfilling to be part of this project, and it makes me want to do more and continue to do more with this group.
Students at Seattle University get the opportunities to learn about how to apply engineering in ways that are often non-traditional. And that makes a profound impact on people's lives. And when you see that transformation, it's remarkable.
You don't want to just do one village, you want to do hundreds of villages. We learn a lot every time we do one of these. I think if we keep doing it, we'll be able to reach more and more people in a much more efficient way and effective way than we've ever been able to before.
At how many people are involved when you get to a Center for Science and Innovation, which is by far and away the largest project that Seattle University has ever done.
This fabulous new facility at the gateway to our beautiful campus represents the growing importance of STEM disciplines, both here at Seattle University and in the modern economy.
This new building will grant students a better education because of the emphasis that there is on hands-on research.
at how many people are involved when you get to a Center for Science and Innovation, which is by far and away the largest project that Seattle University has ever done.
This fabulous new facility at the gateway to our beautiful campus represents the growing importance of STEM disciplines, both here at Seattle University and in the modern.
I think we're the only team presenting in this room, and then other Kenworth teams are presenting somewhere else. Maybe. No. Oh.
Maybe they're sitting in the crowd. I don't know.
Excuse me. Who is the Kenworth team?
Who is the second? Who's the ECE Kenworth team? Who's the second Kenworth team?
I don't recognize any people. Oh, otherwise. Is this like
Maybe find I'm pretty sure they can hear us if we just speak up even without the mics.
Oh, okay.
I think it's just for the video.
I guess we should chill. Wait till
1 minute.
I'll start until like they come back, I guess.
Yeah.
Hello!
Okay. Hello, everyone.
ECE 19.6, are you here? Oh, they're coming.
Okay.
Okay, all right.
We're good. Just want to hit off like a bandage. Just get that.
This is no stage life. Just start sweating.
All right. Hello, everyone. We're Team ME 19.2 at Seattle University, working for a Kenworth truck company. I'm In Sung.
I'm Mark.
I'm Charles.
I'm Brian.
Our faculty advisor is Dr. Yenlin Han, and our sponsor is Stan DeLizzo. So our presentation is going to be broken up into three main components. We're going to go over the problem description and the background, the core solution, how we solve our task, and then our technical overview of the necessary components we need to solve our task. So a little bit of background. Kenworth, they're a company that specializes in making semi-trucks, and their goal is to make self-driving trucks. To do that, they've sponsored a team in the previous year. Oh my gosh. Okay, well, they sponsored a previous team, INT 17.4, and they developed a system that could autonomously back the truck to the trailer. It requires no human interaction. It just starts automatically. However, even after the truck connects with the trailer, it's still not ready to set off. Trailers have an emergency brake that can only be disengaged when they're supplied with pressurized air from the truck. So our task is going to be to create a system that can make that connection between the truck and the trailer, which is that right there. These connectors are called glad hands, and glad hands they're the things that provide the pressurized air from the truck to trailer. They've always been connected manually up until this point, and we have two videos to show you how they're connected. This is how you attach a glad hand. And this is how to detach a glad hand. And so our goal is going to be to automate this process.
So as you can see from those videos, based on the aluminum angle bending, this is a pretty physically arduous process. So we've developed a replacement connector to replace the truck side glad hand called the mech hand. This mech hand, has an internal mechanism, three main rotational components. Those rotational components they rotate freely when driven by an external mechanism, and then when they meet resistance, they produce an actual force that brings the flanges into a locking position, removing the need for a large input force during the connection process. So in order to, so this is a short animation of the internal mechanism of the glad hand. You can see the drive shaft on top, and then that lower cam mechanism that's responsible for moving the flanges back and forth. So in order to manipulate the mech hand, we built a specialized gripper. This gripper is basically a slightly more complicated cordless drill. Also three main components. It has two clamps. Those are responsible for clamping around the exterior of the mech hand. It's got a torque limiting clutch. And then finally the shifter in the back. That shifter is responsible for directing power throughout the mechanism, and that allows either the clamps or the central drive shaft to be driven by only one motor. That motor happens to be electric but can be swapped out for pneumatic, and the shifter is run by a pneumatic actuator. So this is a picture of both components on top, and then below you can see the mech hand in the position where it would be grabbed by the end effector. Finally, for positioning of the gripper end effector, we needed a terminal guidance system. So we have a camera mount that's cantilevered out in front of the gripper. That camera mount, when we're moved into a position that's close enough to the trailer glad hand, uses a basic computer vision algorithm to identify within about a millimeter the position we need to move into to mate the mech hand with the glad hand. And Mark's going to tell you more about that.
So in the circle there red is where the position of the camera would be. For the gripper camera, we're using a simple webcam that would mount it on the end. What the goal of the gripper camera is line up perpendicularly with the glad hand on the trailer side, and then from this point of view, we're doing image processing on a 2D image plane, and we're going to search for circular objects. So we're going from the image on the left to the image on the right. And I'm going to talk to you for the intermediate steps. So here we have our original image, and then next we apply some filters so we can find edges in our image. Once we have these edges, it's very clear we see we have some strong circular objects, and we can search that space for it. And once we have that, we have the circular object here. We find the center point of that gasket, and then we can relay that to our gripper and move it in alignment so we can get the mating process. But before we can do that, we have another camera system to move our gripper camera into place so we can analyze the glad hand perpendicularly as shown before. This camera system used Intel RealSense depth camera and is set up on the back of the cab, looks at the trailer, and then on the left is the glad hand configuration that we'll be spotting. And we're looking for the emergency glad hand, which is shown in the bounding box in blue, and we're going to try to find that. And I'll show you the intermediate steps for this. So this is, again, this is the original colored image, and this is the raw depth information that we're getting from the Intel RealSense. Right now, it's pretty obvious to you that you can't make much out of this right now, so we're going to do some post-processing. So right here, the black represents the foreground objects that we do care about, and the white represents the background. So we can keep processing this, removing the background, and continuing until we have contours that closely resemble the objects we do care about. Once we have these contours of the objects, we can classify them based on image parameters we have and the actual physical shape of the glad hand, and we can remove the ones that we don't care about. So now we only have the emergency glad hand in our scene. We can slap a bounding box on it, and now we have the red circle sampling the depth information, and so now we know how to move our gripper system so our gripper camera can align up with it and do the image processing.
To test our system, all of our components are mounted on a large metal frame. On the left side is our glad hand connector, on the right side is our depth camera, and in the center, our gripper is mounted on a motorized stage. To control our system, our main program was run on a laptop. Our motorized stage was controlled using a Raspberry Pi, and our gripper was controlled using an Arduino. The Raspberry Pi, the Arduino, and the laptop communicated using serial communication. Because the gripper had to go through a series of precise movements, several limit switches were mounted throughout the gripper, which are designed to be activated throughout the connection process. Now Mark is going to show how the computer vision works using the test rig.
So here, this is the depth camera working. So it runs the computer vision processing, it finds the glad hand, and moves the gripper camera into position. And so as you can see, the gripper camera, the webcam, aligns up with the glad hand roughly, and then we can go on the second computer vision suite and analyze this image and move the gripper forward a little bit more.
So once our gripper is moved into position, say in this prototype video, we're doing it by hand. After the terminal camera gives us a location, gripper moves into position. At this point, with the mech hand prearranged at a 90-degree angle to the flanges on the glad hand, then we engage the motor. And once the motor is engaged, that rotates the mech hand flanges into position until they impact right here. After that point, the motor continues to rotate. At this point, it's articulating the internal mechanism of the mech hand, which is causing the flanges on the exterior to clamp against the glad hand. Once the mech hand is securely attached, we activate our pneumatic cylinder right here, shifting us into position. That allows this lead screw to then move the clamps back, releasing the clamps so that we can then move the gripper out of position. So the reverse of that process, moving in by hand, we activate our pneumatic shifter, engage the drive motor, as the clamps come down, the drive shaft from the gripper engages with the mech hand right there. And then we perform the reverse process in order to rotate the mech hand flanges away from the glad hand. This process has been pretty slow. This is the system running at full speed.
All right, so to integrate our proof of concept into actual Kenworth trucks, we have some workspace constraints to consider. The four main constraints is the trailer swing, the 42-inch workspace between the back of the truck and the trailer, the location of the trailer glad hands, and the 0-inch clearance between the trailer and the chassis. These are important because in situations where the truck makes a very sharp turn, some of these parameters change. The workspace between the truck and trailer is significantly reduced from the trailer swing, and that is where the 0-inch clearance becomes very important. If the system was mounted above the chassis, then it would be damaged by the trailer swing. So for this system to work, it'd have to be mounted below the chassis and underneath the chassis. This is a recommended 3D system for implementation on Kenworth trucks. It moves in 3D. The upward and downward motion is provided by a lifting column, and the left to right and forward-backward motion is provided by 2 linear actuators and a guide rail. And this is the recommended mounting position on the chassis, preferably on the driver's side, because the particular trailer given to work with by Kenworth had the glad hands located on the driver's side. So this would make the connection from the trailer glad hands and the truck glad hands simple. And so based off of what we've learned from this project, these are our recommendations for the mounting position and the 3D system. We'd like to give thanks to everyone who made this project possible. We'd like to thank the people at Seattle University, Kenworth Truck Company, and T0 Racing. Thank you. Do you have any questions? Yes.
Where does the airline actually go into the mech hand? So at the bottom of the mech hand, they're vertically aligned, so there's a hose insert, and that's tapped with a 1/2 inch. That hose insert right here at the bottom, that's tapped with a 1/2 inch MPT thread. And so in operation, the turret that's highlighted right there, when it's not engaged with the drive shaft, it's capable of rotating freely. So the hose isn't going to produce a torque on the mech hand while it's attached.
Oh, okay.
I don't need the mic. Where would you, it's unclear to me, where would you recommend mounting your actuation system for a production installation? On the common to the cab, or common to the tractor or the trailer?
Common to the cab. So we can't control any aspects of the trailer side. So we're working specifically with Kenworth's cabs. So that's why we're choosing to mount it on the chassis side, as it provides the most support and also in between the chassis, there's a bunch of other fixtures where we couldn't, that would prevent us from mounting there.
What did T0 Racing do?
So that would be my father's business right there, and probably 75% of the CNC machining that you saw in that video was performed there. So
a lot.
They got a spot on the acknowledgement slide.
What's the history of the term glad hand?
So the term, it refers to like shaking hands, coming together like this. So the connector it's called androgynous because it's not relative. There's no male and female connector. And it's just as they come together and then rotate. And that's the etymology, I believe.
Does this system require any interaction with the human operator at all, or is it fully autonomous?
So the problem as it stands, our gross movement system was just a suggestion. So we didn't solve the problem entirely. We showed it a good time. But the main goal is to, yes, make a system that's completely autonomous.
Currently, our 1D proof of concept that we made out there in the booth, it does run autonomously. We do have some checking to make sure we don't break anything, but so far all the tests have been run so far quite successfully with a few kinks in here and there, but in the future it will be completely autonomous.
So what will next year's project do?
I can't say about that.
Yes, these gentlemen right there.
It has something to do with trucks, I'm pretty sure.
Any other questions?
I'll just mention it. One of the challenges that we gave them was to be able to hook up to virtually any trailer. And it has to make that connection with the glad hand and then get out of the way so that the trailer can articulate. So it was a challenging project for them.
Well done.
Well done.
Thank you.
I'll see you outside.
Yeah, put one in your pocket and then clip it on kind of center.
Okay. It's gonna like weigh down my pants.
Yeah.
Put it in your pocket.
Okay. Put it in your pocket. Where'd you put it? And then this thing works?
Yeah.
Oh, my ear is beeping. What?
Got your phone on silent?
Oh, let me check. Yeah, probably. He is? I don't know. I think when we're ready.
We're going to wait like one more minute.
Let more people come in.
Yeah.
What was that? Back break.
Are you Casey?
In this session, which is also the last session of the day, our ECE presentation. So thank you for joining us. Our next presentation is ECE 19.6, and without further ado, I'll just turn it over to you. So.
Thank you. Hello everyone, we are ECE Team 19.6. Our project is machine learning for weight audits. Our sponsor is Kenworth.
I'm Ariel Harris.
I'm Edie May.
Paul Franklin Okomba.
Sean Wright. Our faculty advisor is Dr. Mehmet Virkash. Our liaisons are Thomas Lee and Brandon Singh.
So this is our agenda for today. We'll first go through an introduction of our sponsor company and the project they presented us with. Then we'll go into the current state of that project and how we progressed through it, show you a final result and a demo of our graphical user interface, and go into our final conclusions. So our sponsor is Kenworth. They're a subsidiary of PACCAR that started in 1923. They've since become one of the largest truck manufacturers in the nation. And the key to their success is their ability to create customized trucks according to unique customer specifications, which is where our project comes in. So we've been asked to utilize machine learning to create a program which will help to improve the accuracy of their weight estimates that they provide for every customization. So these estimates need to be as accurate as possible for more weight-conscious customers. These customers include anyone that's focused on transporting products across the nation. The interstates have something called a bridge law, which regulates the weight that can be on any axle of a truck. So if a truck is estimated to be a certain weight and it comes out way over that weight at the end of manufacturing, that's far less product than can be transported.
So machine learning is essentially a method of data analysis used to automate end-to-end processes. And it's all about learning and identifying any type of patterns, and there are many different applications of machine learning out there. One of the most prominent application in the current day is Google Maps. So what Google does is it collects a bunch of data from its user, processes that data through their machine learning algorithms, and estimates an output that tells the user how long it takes for them to get from one place to their final destination. So this is an example of what machine learning diagram looks like. So first we have training data that goes training the machine learning algorithm to produce some type of model. So when a user inputs some type of data into this model, it will make that prediction and evaluate it whether it's correct or incorrect, and then the data will go back into the machine learning algorithm and get retrained.
This is the layout of the program we'll be providing. There's 3 main sections: a database, the graphical user interface, and the actual machine learning algorithm itself, all of which will be hosted on Amazon Web Services and will communicate with each other through a bridge of connection written in Flask. These 3 main sections are how we're going to walk you through how we progress through our project. So data engineering is the first step, and it's how we developed our databases. The first step in developing these was to organize and filter through all of the raw data provided by Kenworth. This left us initially with about 97,000 trucks to work with, defined by 50 features. All of these features are things like hoods or rear axles or anything identified by our liaisons as something that would greatly affect the weight of the truck at the end of the manufacturing process. Our next step was to match those 97,000 trucks with the scale weights after they've been manufactured. Unfortunately, we didn't have access to one of the manufacturing plant's data, so we were left with 64,000 trucks to work with, and we also narrowed down our features to include 44. This initial data set defined every one of those features by a 7-digit sales code, and we decided in our second data set that we would replace that 7-digit number with the actual weight of every component. So at the end of this step, we were left with 61,000 trucks defined by 31 features. And our final step was to remove any anomalies found in the feature selection process that we'll talk about next. This left us with a finalized data set of 58,460 trucks defined by 31 important features. These are examples of both of the data sets. So the above one is where the features are defined by that 7-digit sales code, and the lower one is where it's defined by the weight. And so we can see the hood is no longer defined by that 7-digit number. It's defined by 154 pounds. And the zeros in each set simply means that that component is not part of the customization for that truck.
The next step in the data engineering is feature selection. All machine learning algorithms require a consistent input vector. We had a total of 31 components that we could potentially use for the input vector. We want to narrow that down as much as possible to increase the efficiency and accuracy of all machine learning algorithms. So we used a correlation heat map to compare each component to the total weight to see which components affected the total weight the most. And we chose any component with a correlation coefficient above 0.2, and we put that as the input vector. The next step on the agenda is the machine learning algorithms. Our first algorithm was multivariate linear regression. It's the simplest and most basic form of machine learning. It plots a line of best fit to the data. So for our data set, we see linearity between the actual and predicted weight for most of the trucks. Each one of those blue dots is a truck. We did notice 2 anomaly clusters to the left. And doing exploratory analysis on the results, we identified these outliers with our liaisons, and we found trucks that had scale weights less than 5,000 pounds, which is impossible because cars weigh 3,000 pounds. So a truck wouldn't be that light. And the left graph here is the prediction error by model. We could see for the model 410, it has a prediction error of over 6,000 pounds, which means the prediction was 6,000 pounds off of the scale weight for that truck.
So there are 3 things you want to avoid in any training of a particular model. The first one is the noise. As you could see from the previous slide, we were able to identify outliers. Those are trucks essentially less than 5,000 or 8,000. The second factor is the variance. As you could see, the truck model 410 has a minimum weight of 3,000 and a maximum weight of 21,000 with a huge standard deviation of 5,912. And the last factor is the truck model count, because that could bias our training. And for instance, the model 602, which is one of the newer models, has only got 1 truck in the training set. And that would make predicting the weight of such a truck practically impossible. So in order to be able to give the prediction with accuracy, we had to find an algorithm that could cope with this sort of data. So we went for a gradient boosting regression trees. It is an ensemble learning technique. It means that it uses a set of many weak models, some of which might overfit or underfit. And it uses that to limit the error and find a better prediction. After running that, we were able to recover the feature importance. Remember, we had to reduce our vector meaning the number of inputs that we were using. So here we have 22 features that are categorized by their importance. You could see that rear axle is 89%, as opposed to front brake, which only has 2% of importance in the final weight decision. After running that, we were able to recover a very nice linear trend, meaning that our predicted weight actually matches the actual weight fairly well. And then our box plot are the same for the actual weight versus the predicted weight. And in terms of error reduction, we were able to, going from the linear regression to the gradient boosting, we see a huge reduction in error weights with most of the trucks under 200 pounds. And imagine 21 pounds of a truck, you only have 200 pounds of error, which is less than probably 1% on average. And here we could see on average that we are able to, on average, to get an error of less than 1% in our prediction. So the last step involved, because we had been training on SageMaker on AWS, we had to deploy this model so that it can be used later in a graphical user interface that later Edie will demonstrate.
So for a graphical user interface, there are many different features to it. And the first one is login authentication, which requires the user to have login credentials to access any of their other features. So one of them is user input for XML and CSV truck orders. So this is where the user will input some type of CSV and XML order into the graphical user interface. And what our system does is it extracts all the data from it and prints it out and also shows the user. And this is done by using XML tree and Panda modules in Python. We also have a file retrieval system where the user can go back into the database and retrieve any type of files that they have once inputted into the system. And the last thing is the truck data, which is the 58,460 data that Ardo has mentioned previously in her. And so that is inserted into the database, and it could be dynamically updated when a user inputs any type of files that I mentioned in the user input section. So I'll be going over our results and our demo for our graphical user interface. So after our team has worked hard to try to get fulfill the scope as much as we could, we have completed the machine learning algorithm, the API, and the graphical user interface, as well as the integration of all the software combining the graphical user interface with our machine learning algorithm. So now I'll be going over our demo. So to access anything, if we click on other features, it will tell us to require us to log in. So this is the page where you can retrieve any files that have been inputted before. These are just our test files that we tried. So we could click this button here, and you could get the exact same file. We also have the truck data sample, which shows a brief example of what our data looks like in our CSV files. And I limited to the amount of features that are shown here because it does slow down our website. And finally, for our machine learning algorithm section, I will be inputting a truck test file, and this file contains all the truck data that have already been processed before. So this means that the trucks have already been built, so we're just using this to validate our machine learning algorithm. So when I click submit, we get rows of different trucks that have been built before. And we're going to demonstrate for row 0, which this model has a total weight of 15,077. So we're using 22 features to find the estimate weight in our machine learning algorithm. So when we click that button, we calculate the weight estimate. And we come down to 15,120.38 pounds, which is only a 0.29% error compared to the actual total weight of this truck. And this is our overall input vector and the 22 features that we used to calculate this weight estimate.
The final part of the agenda is our conclusions. For our final budget, we only had 2 expenditures, travel and subscriptions for Amazon Web Services, for hosting the GUI and the machine learning algorithm. We came in well under budget.
We've also come to a lot of key insights both for our team and for Kenworth. So for our team, we got to really understand the complexities of data engineering and also how that plays into the understanding of your data set. So the size or the amount of data you have, the type of data, and the quality of that data
greatly affect the machine learning algorithms available to you to solve whatever problem you're dealing with. And for Kenworth, we identified a lot of issues within their data, both in how it's accumulated, the actual quality of that data, and the content. Just a correction from earlier, the 602 is actually an older truck that is no longer built anymore, so the one value we had was accidentally entered, and we actually shouldn't have received it because it shouldn't be calculated anymore, and we had a lot of other issues like that. Another issue with the data was possible errors with the scale weights. It was unclear if this was from the actual weighing process at the end of manufacturing, or if it was clerical when the actual weight is entered. And we also got to provide Kenworth with a better understanding of how their products are correlated. We saw in the correlation heat map that Sean talked about how every part plays into the weight of the truck. And a lot of that, everything above that 0.2, really reaffirmed what our liaisons already understood from actually working with the trucks, but it was nice to be able to actually prove what they were viewing is happening. And finally, we have our deliverables for Kenworth. We'll be giving them the graphical user interface with a user manual, so anybody not familiar with the project will still be able to use our program. We'll have access to the dynamic data set, and we'll have a documented insertion code, so any new data that's used to possibly retrain the model will be able to be inserted and formatted in the same way. And of course, it will have access to the machine learning algorithm to produce accurate predictions, and it will all be hosted on AWS for easy access. Any questions?
Hello. It's on. Hi, can you? Okay. So just a question. Just out of curiosity, what did you guys host on AWS? You had the GUI on AWS, the database, and also the SageMaker, correct?
Yes.
So what did you host for the database?
So it's actually through the GUI.
Okay.
What Edie showed is a combination of all of the databases through the GUI itself. And then everything, like any new orders that are entered, will also go into that database through the insertion code.
Okay.
Yeah.
And
Okay. Yeah.
the machine learning itself is on AWS. That's the only thing that sits there as an API that the front end can query from any place, from the local host to any other provider.
So the GUI wasn't hosted on AWS?
No, the GUI itself is not on AWS yet.
Okay.
So the GUI was originally hosted on AWS Beanstalk, but however, we made several different changes on it, so we haven't actually uploaded that final GUI onto the Beanstalk to show you guys for a demo.
And then how long did you take to train that model, and was Jupyter Notebook easy to use?
Yes, so at first we were training on our computers using the Jupyter Notebook, but then we had to use XJBoost, which is Amazon's gradient boosting library. So we had to train on the cloud, and then we used SageMaker, which makes the entire process from training to deployment relatively easy.
They don't all need to be that technical. They'll answer softball questions too.
Yes.
Yeah, I'll ask a question. It sounds like you ended up with 22 attributes that you used to
Yes, sir.
try to analyze. If you used half as many, would you be almost as accurate? Or if you used more, would you get more or less accurate?
The issue comes with identifying what is relevant to trucks, and not all trucks are built the same. There are parts that are in a truck that you cannot find on the other trucks. So if you were to divide in half, you would actually degrade your accuracy. I think it would affect the accuracy of your predictions because you would remove some of the data that is relevant to the final estimation.
Our first initial assumption was to create an algorithm by model, so that way if model 1 uses axles, rear axles, hoods, and model 2 doesn't, there will be different input vectors per model. But we just ran out of time, so we couldn't implement that.
Yes, sir?
So in your example, you used 22, and you said that there was 31 that were significant inputs. What did you use to rule out the difference?
So we used Panda's Python library as this correlation feature that helps you find the correlation between the different parts. That's what we used to rule out. And we had an alternative method that we did not include here, which is called OChem, which helped corroborate our findings. So essentially, Panda helped us find the correlation.
The OCAM Panda uses like linear regression, and OCAM uses statistics. And the way OCAM works was when we ran it, we did it by model. So instead of suggesting model type and engine as major components, it suggested the smaller ones because each model has the same major components. It just has different smaller ones, in essence.
Will this information be used in some way to retrofit the parts of the truck so that you have lighter axles or something?
That wasn't necessarily the goal of our project. We're not dealing with the parts, we're dealing with the end result of the parts all come together as the truck's final weight.
But you could argue that knowing how much your truck would weigh, you could make a better decision as to if you would buy that truck or if you would customize in a different way to get to a lighter truck.
We have time for one more question.
So on the GUI, does it, if you load in a set of specs that isn't currently in your database, and it returns an estimated weight, does it tell you what the estimated error is?
So it can't tell the error. The ones that we were showing were the validation set for our data, so it actually had the total weight. If you're to enter a new truck, you don't know the total weight because it hasn't been manufactured yet, so we can't provide the percentage error.
Okay, so if you had a set of specs that doesn't align with your database, a whole different kind of truck, would it give you any warning that I don't know how accurate I'm going to be?
So also in the GUI, we have another data set that's all of the sales codes and their connected weights. So it would take all of the new input vector and try to find the scale weight. And if there's no scale weight, it puts in a 0, like we saw in the data set that deals with if the component isn't there. So it would produce that, what Edie showed as that list of features, it would have 0s for the ones that aren't available.
Yeah. But it would still be able to give you a weight, an estimate, because it knows the pattern of that type of model. So in some sort of way, yes, you would still get an estimate. You just need to validate that once the truck is finally built.
Okay, let's thank you.
We have to give it to them.
So I've been at Seattle University for 11 years, and there have been so many changes in the College of Science and Engineering. I think the biggest change has been the fact that we have so many more students than we did 11 years ago. We've grown by over 50%. So STEM is becoming a much more popular field of study. Another big change has been the way in which we have really created an amazing culture of undergraduate research. And so many of our undergraduate students have the opportunity to stay on campus and to do research under the mentorship of a faculty member. I'm proud of the impact I've had over the last 11 years through the hiring, development, and retention of amazing faculty members who are truly dedicated to student success. Today, Seattle is home to some of the world's most valuable startups. And look at the success stories that have come out of Seattle. Microsoft, Amazon, Expedia, Zillow, Zulily. The list goes on. And Seattle has created this amazing gravitational field that's pulling in other companies. So Google is here, Apple is here, Facebook, LinkedIn, Alibaba, Tencent. Seattle is where it's at with software, and our students know that. This is why enrollments in computer science have been growing so rapidly. Seattle University is changing. The College of Science and Engineering.
It's Team ECE 19.1, and the sponsors the Boeing company. So I'll turn it over to 19.1, and let's welcome.
Good afternoon, everyone. We're Team ECE 19.1, and today we're here to present to you our final capstone project. Our project is to develop a power quality data processing software tool for the Boeing company. My name is Kadrian Rickman.
I'm Rasmus Nystrom. I'm Jeremiah Kalmus.
I'm Huivo. Our faculty advisor is Mr. Richard Bankhead. Our liaison engineers are Dr. Kimir Karimi, Ms. Evelyn Matheson, and Dr. Eugene Solodovnik. Did you know the Boeing company started right here in Seattle in 1916? They're the largest manufacturer of airplanes in the world. They manufactured airplane models such as the 737, 747, 767, 777, and their new airplane, the 787. It's considered a more electric aircraft. With our sponsors' continuous contribution in research and development, this is where our project comes in. And now Jeremiah will talk to you about the background of our project.
So with the introduction of the Boeing 787 and the more electric airplane, Boeing's goal was to create an airplane that would be able to be more fuel efficient and travel greater distances without needing to stop to refuel. They did this by making the airplane design lighter, and this was done in many ways. One way was to redesign the airplane frame and use less aluminum and more composite materials. Another way was implementing certain systems, not pneumatically, but being powered on the electric system, such as airplane cabin pressure system, and also the removal of gearboxes. And the gearboxes were large, heavy pieces of equipment that kept the airplane electrical frequency at a constant 400 hertz. Now, with the removal of this, it helped Boeing indeed achieve their goal of a new airplane that was more fuel efficient. However, it introduced variable frequency into the electrical power system, which was a challenge, especially analyzing during testing. This is where Team ECE 19.1's project comes in, where we are to make a software processing tool that would be able to help Boeing in analyzing this electrical power system. So certain requirements for this software tool was it needed to be created using MATLAB. It needed to read in ASCII data files, up to 6 channels in each data file, and it needed to support certain AC algorithms, DC algorithms, as well as support frequencies between 360 and 800 hertz. It needed to have a graphical user interface so that it would be easy for the user to navigate the tool, as well as a graphical data display that visually showed certain plots and waveforms plotted from the input test data. And our design was built using a built-in GUI environment in MATLAB called App Designer. This gave us a lot of utility to make a very clean, nice-looking graphical user interface. And we will go ahead and talk about DC algorithms in our tool.
Okay, so for DC signal, we need to find the max, mean, and mean value of the data set. So for this function, instead of looping through the whole data set, we use the built-in function of MATLAB because it's easier to implement and it can be executed faster. Another DC function is peak-to-peak ripple. And for this function, we need to find the difference between max value and mean value over the specified window. So this function, from the previous function, we already know how to find the max and mean value. So for this function, we just subtract the mean value from the max value. For the AC signal, there are some simple functions like finding max, mean, and mean value as we did for DC signal. And finding the RMS value is the square root of the mean square value of the data set. And the total harmonic distortion is the ratio between the total power of all harmonic components and the power of the fundamental frequency. And the crest factor is the ratio of the peak value to the RMS value. So the next function is modulation. And as you can see on the screen, for this function, we need to find the difference between max peak and mean peak of the signal envelope. And for this function, we need to extract the up envelope by calculating the local maximum over each cycle of the waveform. And the waveform cycle will be calculated by using zero crossing detection. The next function is frequency spectrum analysis function. So for this function, it will apply for both DC and AC signal. And this function will convert the signal in time domain into frequency domain. And for example, as you can see on the screen, the signal in red color is the combination of 2 sine waves. And by converting it into the frequency domain, you can see the amplitude and the frequency of each sine wave. However, when the user specifies the signal is not always periodic, and this will cause the spectral leakage, which the energy at one frequency will leak into another frequency as shown on the screen. So to reduce the effect of spectral leakage, we apply the handling window. And you can see that after apply the handling window, the spectral leakage will affect the smaller area frequency. And next, Jamila will talk about the power calculation.
So with certain calculations, such as real and reactive power, these were more difficult to compute because of the variable frequency of the data that we received. It created signal distortion in the data, or in the signals. And for those of you that are unfamiliar with signal distortion, I'll go ahead and explain it. On the screen, we have a voltage versus time signal, and it is sinusoidal and periodic. And on the next slide here, we have a very similar signal, but that ripple pattern we see in there, that is a byproduct of the variable frequency and what we refer to as signal distortion. So these are the equations we used for our power computations. We had to use the Fourier series, which are more difficult equations to work with, and we had to use these instead of the more simplified versions because we had to deal with this distortion. Another feature of our software tool is the moving RMS window. And so we can see on the screen here that we have a blown up version in the foreground of what is the image in the background. So that big blue block is actually just a very densely packed waveform. So this subset in the front is what's in that red rectangle, and the RMS will be calculated of that subset and plot as a single point, as shown on this slide here with this red dot. And that window will pan across the entire waveform, creating a new signal so that you may see how the RMS changes over the course of the waveform. And lastly, we have implemented power interrupt. And power interrupt is calculated by the user specifying a certain threshold voltage. And if a subset of the data lasts for longer than one period, below that threshold value, it would be considered a power interrupt. So for example, if we pick a threshold value of 300 volts, we can see at about 21.5 seconds that the magnitude drops below that threshold value and stays there for quite a long period of time. This is what we would consider a power interrupt. Now Rasmus will go into a short demonstration of our software tool.
Yeah, all right. So as we mentioned, we developed this tool using MATLAB, and we've actually installed it here in MATLAB as an application. And this is great because this allows Boeing to easily install it, but also share it amongst themselves. And when we open it up, we get what we call the main window. This is where the analyst can look up the user manual, but also load in a file. So we're going to go ahead and load in a file here. And it's going to prompt us if we want to do a DC or AC analysis. And for this demonstration, we're going to go ahead and do an AC. And then we're going to choose a data file that Boeing has provided us with data recorded from the electrical power system. So once we load it in, we see now we have 6 different channels. So this means there's 6 channels of data within that file. And if we click any of these, we're going to be able to select one of each channel. And we can select up to 6 channels if we wish to do so. And once we select these, we get up what we call the main analysis window. And here we have all of the raw data in the graphical data display, which is highly condensed, as Jeremiah pointed out. We also have utility options such as zoom in, zoom out, resize. And to the right here, the user can also specify if they want the x-axis limits or the y-axis limit to get a better visualization of the graph. We also have the calculations here, the more basic ones, such as max, mean, peak-to-peak, RMS, crest factor, and total harmonic distortion. What's great about these values is they automatically update to what is shown in the graphical graphical data display. So if we were to look closer to a subset of this plot, these would update. And I'm going to go ahead and demonstrate that. So we're going to select a smaller section between 1 and 1.1. And now when I hit enter here, we're going to see those values update. And we can also see that there is a clear waveform here. We also want to demonstrate some of our functions. And we're going to demonstrate the upper envelope, the modulation of the upper envelope, which we mentioned. And this is where we plot the waveform of the upper peaks. And here we see we get a new waveform now that plots the upper peaks. And we know that we're calculating the upper envelope because all our calculations are now positive. The second calculation we want to show is the calculation of frequency waveform. So we're going to go ahead and click it here. And we get an option to plot it in decibel or not. And we're going to go ahead and plot it in decibel. And now when we do that, we get a second window here that shows the frequency waveform. And this window gives the user a little more utility because we can actually look closer on certain points. So, and we also display the fundamental frequency, which is a value that Boeing is really interested in. And that is all for our short demonstration. So we're going to go back to our slides. Next is testing. So we performed user experience testing on our software. And one of these were point and click testing. This is where we tested all the features and all the functionality of our tool so we could identify bugs and resolve them. We also provide our Boeing liaisons with multiple earlier versions of our tool so they could try it out and test it and give us feedback on how to improve our product. Next, Jeremiah is going to talk about our algorithm validation.
So to verify that our algorithms are accurate, I'll go ahead and explain it. But as I do, on the screen here is a table showing outputs that we received from our software tool, verified points that we received from Boeing so that we can cross-reference, and as well as outputs from Microsoft Excel's algorithms. So for rudimentary functions like min, max, mean, and RMS, we took data from sample files that we received and put them into Microsoft Excel and use those algorithms to cross-reference with that of our software tool. For more complex algorithms such as real and reactive power, we used a two-step process. First, we made our own non-distorted signals so that it would be easier for us to compute by hand. We computed real and reactive power by hand and compared them to the output of our software tool. Once we were satisfied with that, we went on to the second step, which is using the Boeing test data on our software tool and comparing them with expected results given to us by our liaisons. And now Hui will go further in explaining some different tests.
So to test the frequency spectrum analysis function, we generate our sample signal and compare our output with the expected result. So for our sample signal, we expect to see the frequency component of 5,000 and 10,000 Hz. We also tested function with the Boeing dataset. And for the Boeing dataset, they expect to see the fundamental frequency at 650 Hz. And here is our output plot for our sample data. You can see that we have the frequency component at 5,000 and 10,000 Hz. For Boeing dataset, we also have the fundamental frequency at exactly 650 as expected. And for the modulation function, we tested the same way we did for the previous function. So besides testing with the Boeing dataset, we generate our sample signal. And with the sample signal, we expect to see the difference between max peak and min peak of the upper envelope around 2 volts. And below is our output plot. As you can see on the screen, the difference between 2 peaks of the upper envelope in blue color is around 2 volts as expected. And next, Jeremiah will talk about the budget.
So for our budget, our project, we were allotted $1,500, and the breakdown can be seen up here on the screen. And we've spent slightly under $500, so we're on track there. Other deliverables besides our software tool to our liaisons would be a user guide so that they can quickly look up different functionalities of our tool and see them all there, as well as an instructional video that anyone new to our software can easily follow along to get the hang of our software tool. Recommendations, things we recommend if this project were to be continued, would be the improvement of real and reactive power algorithms. When using large data sets on the order of millions of data points, it's not quite efficient enough to be dynamically updatable like min, max, and mean and RMS. Also, another recommendation would be to simply expand upon the tool's functionality to support larger data sets with more channels of data or add a feature like batch processing, for example. That is our presentation. Thank you, everybody, for listening.
We have some time for questions.
I'm obviously total layman in this space, but so this work was done on a 787, and you said it was based on the absence of gearboxes gave some variations in power frequencies, and that led to this investigation in the first place. Do you think it has applicability to other airplane models in a similar configuration? Could it be used for, say, future Boeing airplane models as well?
Yes, it could, most definitely. This is for any more electric airplane type, or really, even if an airplane still has gearboxes on it, it can be used to evaluate those as well. It simply supports variable frequency if you want to use computations that have signal distortion in them. So,
yeah, and to add on to that, if it really needs a file that this supports that type of file. So as long as you have that file with this type of data, you're going to be able to analyze it, whether it's the 787 or any other plane.
Any major surprises you found during your development?
So like working with variable frequency was more difficult than if the frequency was constant. So like calculating for the power, that was more difficult for us.
Yeah. Also, yeah, mentioned that we used MATLAB. We've never used MATLAB before, so that was also a very new experience for us to see what it's capable of.
So if you have to put this project in like simple way, what does this project do like in real life? Like, not technical, but like can you explain it like real life?
It makes the airplane safe.
It validates that the airplane is safe.
Is
The quality of the power is clean.
Yes. Yes.
You know I'm a stickler for time, so we have 3 minutes. We'll just run out the clock. Okay, I think we'll end there. Thank you. Starting shortly.
Economy.
This new building.
Hello, and thank you for taking a few minutes.
You can't do this!
Woo! Come on, come on, come on! Get in the game!
There have been so many changes in the College of Science and Engineering. We've grown by over 50%. So STEM is becoming a much more popular field of study. Seattle is where it's at with software, and our students know that. We're innovating as industry innovates so that our students will be prepared for the jobs of the future.